Welcome to Security and Authentication. This course equips you with essential tools to protect web applications and APIs, from securing identities with ASP.NET Identity to implementing role-based access and mastering JWTs. You'll also explore data protection techniques and use Microsoft Copilot to streamline secure coding. By the end, you'll be ready to build secure, reliable systems. We'll start by diving into ASP.NET Identity, exploring how it serves as the backbone for managing user authentication and authorization. Understanding these foundations is key to building secure, user-friendly applications. Next, we'll focus on role-based access control and JWT authentication, learning how these techniques ensure secure and seamless access to APIs. Mastering these concepts is essential for protecting application endpoints and effectively managing user permissions. Then, we'll explore core data protection techniques, including encryption and secure storage, to ensure sensitive information is safeguarded both in transit and at rest. These strategies are critical for maintaining user trust and compliance with security standards. Finally, we'll harness the power of Microsoft Copilot to implement and debug security features. This hands-on approach will help you write secure, efficient code while leveraging AI to streamline development processes. By the end of this course, you will be equipped to design and implement secure authentication systems, protect sensitive data, and build trust with users through robust security practices. Let's get started with security and authentication.
My name is Paul Party, and I'm your instructor for this course. I've been programming computers since I was in my teens. I love programming because it's like solving puzzles while designing and creating something amazing. My graduate degree is in philosophy, where I learned how to become a better thinker. When I program computers, I can apply many of the logic skills I learned in philosophy. Computer programming not only enables you to build cool software, but I believe it can help make you a better thinker. I started my software development career at Microsoft when the internet was just getting started, and I participated in the internet revolution firsthand. I managed software engineering teams that worked on desktop and web-based software. The internet gave software developers, particularly those working on user interface, incredible new opportunities. From mobile interfaces to websites, software developers are not only creating software that's functional, but also works of art. In my career, I managed and worked with teams at both Microsoft and PayPal that focused on customer-facing interfaces and learned how to make them great. I also spent part of my 20 years at Microsoft in training organizations where I learned how to communicate challenging ideas to new learners. I also was fortunate enough to have spent 15 years teaching non-majors philosophy at a university in Seattle. This reinforced my ability to teach learners difficult concepts using ideas they can relate to. There's nothing more satisfying than to witness a learner having an aha moment where they understand something new. I'm really excited about this program. I believe Microsoft has some of the most powerful and exciting software development tools available, and I can't wait for you to learn about them. I'm confident you'll have many of the aha moments as you gain new skills and reinforce existing ones. The learning experience in this course is designed to give you a comprehensive understanding of key concepts through various learning methods. You'll be guided through interactive, engaging materials that help you build practical and theoretical knowledge. Whether you're interested in front-end, back-end, or full-stack development, this program has the tools to support your growth every step of the way. Throughout the course, you'll be introduced to core concepts and key ideas in videos. These videos are designed to help you understand definitions, processes, and essential steps clearly and concisely. You'll get to absorb foundational knowledge, setting the stage for deeper exploration as you move forward. And when you need step-by-step guidance, screencasts will provide you with a detailed practical view. These screencasts will show you exactly what's on the screen and how to work through specific coding tasks. The course also includes readings that reinforce the key ideas presented in the videos. These readings are more than just supplementary material. They're job aids. You can print them out and use them as a reference while working on assignments or activities, helping to apply what you've learned in real-world situations more easily. Small activities are included to help you check your understanding of key ideas. These activities provide quick, interactive opportunities to practice what you've just learned. After completing each activity, you can compare your work with a fully explained example and answer key. This ensures that you always know if your answer is correct. Practical experience doing tasks you would in a job within this field is essential, and that's where guided labs come in. These labs take you through the implementation of different concepts step by step. As you work, you'll receive feedback and helpful hints, ensuring you can get the help you need when you need it. It's the perfect opportunity to practice in a controlled environment while learning by doing. After completing the guided labs, you'll move on to independent projects, or you try it. This is where you'll put your skills to the test, applying what you've learned in the labs. You'll work through real-world problems, cementing your understanding of the course material. The course will culminate in a practical project leveraging Microsoft Copilot that you can use as a portfolio artifact when you begin your job search in this field. As you progress through the program, the portfolio pieces will become stronger and better representations of the authentic experience you've gained. They'll showcase your understanding of code and the ability to implement different concepts from the developer program. This course guides you step by step from understanding concepts through videos and readings to apply them in activities, screencasts, and labs. Each part of the course builds on the last, helping you gain knowledge and authentic experience. By the end, you'll have completed real projects that not only showcase your skills, but can also be included in your portfolio as you start your career. Everything you do here will prepare you for success as a developer. Let's get started.
Throughout this course, you'll complete several guided labs. These labs are meant to give you an opportunity to practice your newly learned skills in an environment where you can get help and feedback as you complete coding challenges. This video will describe how to complete the guided labs in this course. We will explore a guided lab together so that you'll know what to expect when you come to one later in the course. First, let's check the content leading up to a guided lab. This structured content ensures that you have exactly the skills you need to complete the task. In this instance, there is a practical application video that describes in detail how this concept is used in real-world situations. Following this practical application video, you can review a reading that explains the concept in detail so you can go through this content at your own pace. Next, you'll find a video that works through the guided lab itself. This video won't give you all the answers to the guided lab, but it will provide an overview of the upcoming questions and challenges. Lastly, we come to the guided lab itself. The guided lab is a simulated code environment where you can experiment with code and receive hints and feedback in a realistic coding situation. To start, I'll click Start. In this lab, step 1 is an introduction to if-else statements, so I'll click Begin. Below the simulated code environment, I can find the specific instructions for this lab. Declare the variable age as type int. Place your cursor into line 2, type your answer, and select Enter to check your work. Alright, I think I know this one. I'm going to type in INT and hit Enter. Great, I got that correct, and I got a bit of feedback about my correct answer. To move on, I click Continue. And these instructions say, prompt the user to enter their age, place your cursor into line 4, type your answer, and select Enter to check your work. This one is a little trickier. Let me try type your age. Got it. This feedback for my wrong answer points me in the right direction. Let's try that again. I'm going to erase what I had here and then enter your age. Perfect. I'll click Continue. Let's try one more. Convert the input to an integer using int.parse and store it in the age variable. Place your cursor into line 6, type your answer, and select Enter to check your work. I'm not totally sure here, so I'm going to click on Hint and get some help. And the hint says, use console.readline and then an open and close parentheses, display a message asking their user for their age. Great, that helps. I'm going to click continue and type in console.readline. And I've got it. That's how you work through a guided lab. Some questions will require more complex code to complete, so make sure you're using the hint function when you need it and reviewing the feedback provided for your right and wrong answers. Have fun completing these coding challenges that put your new skills to work.
In today's rapidly evolving tech landscape, artificial intelligence plays a key role in making development more efficient and intelligent. That's where Microsoft Copilot comes in. Microsoft Copilot is a powerful AI-driven tool that can assist developers in writing, optimizing, and debugging code. In this course, you'll leverage Copilot as a thought partner and a code-generating assistant, helping you solve problems, generate code snippets, and enhance your projects. The goal is to provide you with hands-on experience using a tool that real-world developers use to improve their workflow. In the last module of this course, you'll engage in videos, screencasts, guided labs, and independent projects that integrate Copilot. These labs will take you through how to use specific prompts to generate code, optimize solutions, and solve problems. You'll be shown step-by-step how to leverage Copilot's capabilities to strategically approach the final project. During the guided labs, you'll get hands-on experience working with Copilot. These labs are structured to show you how to craft effective prompts and work with Copilot's code generation features. You'll use it to assist in writing code, refining your solutions, and debugging. This practice will prepare you for the independent work you'll do in the final project. After the videos, screencasts, or guided labs, you'll move on to independent activities where you'll take control. Here you'll use Copilot to assist with various aspects of the project. You'll be making strategic decisions, but Copilot will support you by generating code, suggesting optimizations, and helping you troubleshoot. This prepares you to work more independently while still having the power of AI to assist. The final project will combine everything you've learned in the course, and you'll have Copilot as a key tool in your development toolkit. You'll use Copilot to help you generate and refine code as you combine the concepts from earlier lessons. The project is a portfolio-ready artifact showcasing your coding skills and your ability to leverage AI in modern development workflows. To succeed in the final module, actively engage with the guided labs and practice using Microsoft Copilot effectively. The videos and prompts will take you through Copilot and equip you to apply it strategically and independently. By the end of the course, you'll be fully prepared to complete the final project and demonstrate your skills using traditional coding and AI-assisted workflows. Welcome to the course. In this video, we will discuss how you can make the most of each part of the course to set yourself up for success. Whether you watch the videos, complete activities, or work through hands-on labs, each element has been designed to help you master the skills you need to become a confident and capable developer. The first step in every lesson is the videos. You'll be introduced to new concepts, definitions, and key ideas. Watch these carefully and take notes on the important points. The videos provide the foundational knowledge you'll need to build on, so don't skip them. They'll give you the context to understand everything that comes next. After each video, complete the readings. These readings reinforce the key ideas you've just learned and can serve as job aids. I recommend printing out the readings or saving them for quick reference. They'll be extremely helpful when completing activities, working on projects, or just needing a refresher. They're not just supplementary. They help you apply what you've learned to real-world tasks. Throughout the course, you'll find small but impactful activities. These quick exercises allow you to check your understanding of key ideas. Don't rush through them. Take the time to work through these activities thoughtfully. After each, compare answers with the answer key to check how well you understand the material. This is your chance to practice without pressure. At the end of each lesson, you'll encounter practice quizzes. These quizzes are a great way to ensure you fully grasp the concepts from the videos and the readings. Use these as a checkpoint to assess how well you retain the information. If you find yourself struggling, review the videos and readings again. The goal is to build confidence and solidify your understanding before moving forward. When you need to see the material in action, screencasts guide you. These videos show you exactly how to work through certain tasks step by step. If you ever feel stuck or unsure about applying a concept, watch the screencasts and follow along. This hands-on guidance is invaluable for understanding how the code works in real time and applying what you've learned. At the end of each module, there will be graded quizzes. These are an important part of your success as they allow you to demonstrate mastery of the material. These quizzes build on the practice quizzes, and they're a great way to ensure you're ready to move on to more advanced concepts. Treat these quizzes as milestones. Passing them means you're fully prepared for the next challenge. The guided labs are where you'll take the concepts from the lessons and apply them in a controlled, hands-on environment. These labs will take you step by step through tasks, including helpful feedback and hints. The more effort you put into the labs, the more you'll get out of them. It's all about learning by doing, so take your time and ensure you understand each step before moving on. After you've completed the guided labs, it's time to test your skills with independent projects or U-try-its. This is where you'll apply everything you've learned without step-by-step instructions. These projects are a great way to gauge how far you've come and to put your knowledge to the test. Don't worry if you feel challenged, that's part of the learning process. By completing these projects, you'll reinforce your skills and build confidence. Finally, at the end of the course, you'll complete a culminating hands-on project that you can use as a portfolio artifact. This project will showcase the skills you've gained throughout the course and give you something tangible to present to potential employers. As you progress through the program, these portfolio pieces will become stronger representations of your hands-on experience and understanding of key concepts. Success in this course comes down to using all the tools available. Watch the videos carefully, engage with the readings, complete the activities and quizzes thoughtfully, and take full advantage of the screencasts, labs, and projects. Each element of this course is designed to help you master the material step by step. By the end, you'll have a solid understanding of the concepts and real projects to prove your skills. Remember to persist, take your time, and you'll be ready for a successful career in development.
To bring together all that you've learned in this course, you'll complete a project that emphasizes secure coding practices with the help of Microsoft Copilot. By the time you finish this project, you'll have increased the security and improved the authorization process for a web application called SafeVault, a solution for managing sensitive data while demonstrating your back-end development and security expertise. Whether you're improving this app to showcase your abilities to potential employers, deepen your understanding of secure coding, or simply to take on a meaningful challenge, this project is your chance to excel. And don't worry, you won't be working alone. Microsoft Copilot will be your trusted assistant, helping you generate, debug, and optimize your code at every step. In this video, we'll outline the end of course project. By completing this project, you'll develop a fully secure application with essential features like input validation, SQL injection protection, and user authentication. You'll also implement role-based authorization and resolve potential vulnerabilities. Microsoft Copilot will streamline your workflow and help ensure the security and reliability of your code. Whether you're new to secure coding or have some prior experience, this project is designed to be approachable and impactful, helping you develop critical back-end development skills. Let's go over the details. The objective of this project is to improve the SafeVault application, which will include these key components. First, you'll add input validation to ensure all user inputs are sanitized and secure, protecting the application from malicious attacks. Your app will also have parameterized queries. This will help safeguard database operations by using secure methods to handle user-provided data. Also, you'll build an authentication system with a robust login system to verify users' credentials securely. Your app will have role-based authorization, implemented access controls to restrict features and routes based on user roles, such as admin or regular users. And finally, you'll security debug and optimize to identify and fix vulnerabilities like SQL injection and cross-site scripting or XSS attacks. Throughout the project, Microsoft Copilot will assist you with generating secure code for input validation and database queries, developing authentication and authorization systems to safeguard user data, and debugging and optimizing your code to enhance security and performance. This project is divided into 3 structured activities. In Activity 1, you will use Copilot to write secure code for input validation and parameterized queries. You'll also create tests to ensure protection against vulnerabilities such as SQL injection or XSS attacks. Then, in Activity 2, you'll implement and test authentication and authorization systems to verify user identities and control access to specific features. Finally, in Activity 3, you'll debug and resolve vulnerabilities with the help of Copilot, ensuring the Safe Vault application is fully secure and protected against threats. Each activity builds upon the previous one, creating a structured and comprehensive learning journey. Copilot will guide you throughout the process, providing real-time suggestions, optimizations, and support for debugging. By following detailed step-by-step instructions, you'll end up with a polished and secure Safe Vault application ready to be showcased in your portfolio. This project highlights your proficiency in secure coding practices and demonstrates your ability to use AI tools like Microsoft Copilot to enhance your development process. This end-of-course project is an excellent opportunity to bring your skills to life and demonstrate your capabilities as a back-end developer. It's designed to be challenging yet rewarding, leaving you with a professional-grade application and a solid foundation in secure development. Welcome to Securing APIs with ASP.NET Identity. In this module, you'll learn to secure your applications with user roles, claims, token-based authentication, and external authentication providers. By the end, you'll be ready to build secure, reliable systems that protect users and data. We will begin by exploring ASP.NET Identity and understanding its role in managing authentication and authorization for modern applications. Next, we'll examine user registration and authentication and learn how to implement secure and efficient workflows for user access. Then, we'll focus on managing user roles and claims, a crucial step in defining and controlling access within your applications. After that, we'll examine token-based authentication, a key mechanism for enabling secure, stateless communication between clients and APIs. Finally, we'll explore how to integrate external authentication providers, allowing users to access your application securely through services like Google or Microsoft. Securing APIs with ASP.NET Identity is fundamental to building trusted applications that protect user data and ensure seamless authentication and authorization processes. Let's get started with securing APIs with ASP.NET Identity. ASP.NET is a web development framework developed by Microsoft that's widely used for building dynamic web applications and services. It allows developers to create powerful, scalable, and secure web apps, primarily using C#. ASP.NET Identity is a membership system within the ASP.NET framework that manages user authentication and authorization, and roles, ensuring secure access to web applications. In this video, we will identify the key features of ASP.NET Identity and its role in managing user authentication, authorization, and user roles within an ASP.NET application. Let's start by exploring the first key feature of ASP.NET Identity, user authentication. User authentication is the foundation of any secure system. Authentication, or authn, verifies users' identities before granting them access to a system or application. Consider when you log into a website, you enter your username and password. The system then checks if the information matches an existing account to verify it's really you. Authentication confirms your identity and ensures that only authorized users can access your personal data or secure features within the application. Once the system has identified the user through authentication, it needs to decide what actions they are allowed to take. This is where authorization comes in. Authorization, also known as auth-z, controls what a user can do once they're authenticated. In other words, it controls their access based on their role or permissions. For instance, in a workplace application, an employee might only be able to review their personal information, but a manager can approve time-off requests for the entire team. Next, let's explore how user roles work in ASP.NET Identity. Instead of assigning permissions to each user individually, roles allow you to group users within the same permissions, simplifying management. User roles are a predefined set of permissions assigned to groups of users. Instead of giving permissions individually, you assign them to roles. Imagine an online store where merchants can add products to the inventory while customers can browse and make purchases. Each role has different capabilities. Now that we've covered basic user management, we can explore how ASP.NET Identity enhances authentication with specific features like multi-factor authentication, or MFA, which adds an extra layer of security by requiring your password plus another step, like entering a code sent to your device. ASP.NET Identity also provides a password recovery feature. This feature lets you reset your password if you've forgotten it, usually through a link sent to your email. Finally, you will receive a confirmation email during registration to verify that you are signed up. Another feature of ASP.NET Identity is modular integrations. Once you've set up security features like MFA and password recovery, it's important to examine how ASP.NET Identity fits into a larger framework like ASP.NET Core. ASP.NET Core is the foundational framework that supports ASP.NET Identity, providing the structure needed to build secure, cross-platform applications. As an application grows, you might allow users to sign in using their Google or Facebook accounts, making it easier while keeping your app secure. ASP.NET Core integration ensures secure and customizable identity management in any ASP.NET Core app. Along with its cross-platform capabilities, ASP.NET Identity is also valuable for data storage. ASP.NET Identity uses Entity Framework to securely store user information, like passwords and roles, in a database. Entity Framework, or EF, is a framework in the .NET ecosystem that simplifies how developers interact with databases. ASP.NET Identity uses Entity Framework to securely store user data, like passwords and roles, in a database. This setup allows developers to manage database interactions easily without writing complex SQL queries, which streamline data management. For example, when a user registers on an e-commerce site, their details, such as an email and password, are securely stored using Entity Framework, which easily retrieves that information later. Entity Framework allows developers to work with databases using objects, making tasks like saving and retrieving data much easier. Instead of writing SQL queries, you can manage user data using C# code, streamlining the development process. In this video, you learned about the key features of ASP.NET Identity and its role in managing user authentication, authorization, and user roles within an ASP.NET application. By using ASP.NET Identity, you can ensure your applications are secure and user-friendly, laying the foundation for more complex features in the future. Controlling access to your application is critical for both security and user experience. By understanding the core components of ASP.NET Identity, you'll gain the skills needed to manage users, roles, and authentication securely within any application. In this video, we will explain the key components of ASP.NET Identity and how they work together to manage users, roles, and authentication. Before we explore each component, it's essential to understand that these tools work together to create a complete ecosystem. Each component plays a specific role in managing users and enhancing the application's security. Let's examine how each of the key components of ASP.NET Identity contributes to this overall structure, starting with User Manager. User Manager is a component in ASP.NET Identity that is responsible for working with user accounts in your application. User Manager processes operations such as creating, deleting, and updating users, setting passwords, and managing user claims. Imagine using an app where you can create an account. User Manager makes that possible. It manages creating and updating your profile and removing your account if needed. Since User Manager manages account creation, we also need a way to verify that users are who they claim to be. For this, we use Sign In Manager. Sign In Manager is a component in ASP.NET Identity that takes on the responsibility of managing user authentication, processing sign-ins and sign-outs, and ensuring that only users with valid credentials can log in. Think of a time when you logged into an app with your password and username. Sign-In Manager is the part of the system that checks your credentials and securely signs you in. After logging users in, we need to control what they can access in the application. We do this by assigning different user roles to users using the ASP.NET Identity component called Role Manager. Role Manager helps define what different users can do within the application by creating roles and assigning users to them. In an app, Role Manager can assign the admin role to some users so they can manage the system, while others are given roles that allow them to only access certain features. For example, in a company's internal system, you don't want every employee to have the same permissions. Admins should manage sensitive data, while regular employees can only access certain information. Role Manager makes this possible. Finally, we need to store all this user role information in a database securely using the component IdentityDB Context. IdentityDB Context manages the secure storage of information related to users, roles, and claims. IdentityDB Context connects an application to a database, securely storing and retrieving user details, roles, claims, and permissions. For example, IdentityDB Context stores information like user credentials or access level in a secure database for future use. This setup ensures that user data remains available for future logins. In this video, you learned about the components of ASP.NET Identity and how they work together to manage users, roles, and authentication within an application. From authenticating logins to assigning roles and storing user data safely, ASP.NET Identity provides the tools to keep everything operating smoothly. When you sign up for an account on a website, various security steps work together to protect your personal information. These processes ensure that your data is safe when you enter it into the registration form. Understanding how these systems function is essential for building secure, user-friendly applications. In this video, we will describe the steps involved in user registration using ASP.NET Identity, including form submission, password hashing, and email confirmation. Let's examine what typically happens when a registration form is submitted while signing up for an account on a web page. For example, when you sign up for an online store, you might enter your email and password and select Create to submit the form. Once the form is submitted, the system processes the account for creation. This information is then sent securely to the server, where the system processes your details and prepares them for the next step. After submitting the form, the next step is to store the password securely using password hashing. Password hashing converts a plain text password into a fixed length string of characters or hash using an algorithm, making it secure and difficult to reverse engineer. When your password reaches the server, storing it as plain text would be a significant security risk, as hackers or other unauthorized users could easily read the passwords if they gain access to that system. To prevent this, the system uses password hashing, which scrambles the password into an unreadable format. This means that even if someone gains access to the database, they'll only access the hashed version, not your actual password. With your password secured, the next step is to confirm that the email provided is valid and belongs to you. At this point, the system sends a confirmation email to ensure that the account is genuinely yours. You may recognize this step when you receive an email with a Verify Account link. Selecting this link proves that the email is yours, preventing fake accounts and ensuring that you're the one who registered. The final step is to securely store your email data now that it has been confirmed. To do this, ASP.NET Identity organizes and stores information like your hashed password and email confirmation status in a secure database, ensuring security of your account. In this video, you learned about the steps involved in user registration using ASP.NET Identity, including form submission, password hashing, and email confirmation. Every step in user registration, from securing passwords to confirming email addresses, is a vital role in keeping user data safe. Every time you enter a password to log into a website, a series of steps works in the background to protect your information. By understanding how these steps work, developers can build secure systems that keep users' credentials safe. In this video, we will explain the steps involved in user authentication in ASP.NET Identity, including credential submission, password verification, and session management. Let's start by exploring the first step, how users submit their credentials when logging in. Credential submission is where users enter their username and password into a login form. When submitted, the server receives these details for verification. For example, you submit your credentials each time you enter your email and password to log in. Once your credentials have been submitted, the server moves to the next step, password verification. When a user submits a password, the server hashes it and verifies it against the hash stored in the database. Storing passwords as hashes enhances security by protecting plaintext passwords from exposure. This process protects your passwords, ensuring that even if someone gains access to the database, they cannot view or use your original password. Once a password is verified, the next step is session creation. A session is a temporary state that securely maintains users' logged in status during their visit to a website. For instance, a session keeps you logged in as you explore different parts of a website. Without it, the site would forget you after each section, making browsing difficult. Sessions last for a set time and may expire if inactive, meaning you'll need to log in again. This enhances your browsing experience while adding security to protect your access. Sometimes users want to stay logged in even after closing their browser. This is where cookies come into play, typically via a Remember Me option. A cookie is a small piece of data in a website saved in your browser to remember configurations between sessions. When enabled, cookies save login information on your device, letting you stay logged in across multiple visits. Unlike sessions, cookies persist on your device, so you don't have to log in each time you return to the site. In this video, we learned about the steps in user authentication in ASP.NET Identity, including credential submission, password verification, and session management. You can build safer and more reliable web applications by understanding these steps.
In this lab, you're going to implement user registration and authentication using ASP.NET Identity in an ASP.NET application. So in step one, you're going to set up the in-memory database. I have a MVC app here, which I created with .NET New MVC template. In step one, you're going to create the identity context and configure the database to use an in-memory database. The first thing we want to do is define the database context. We're going to go into our applications dbcontext.cs file that's in the models folder, and we're going to add the context for the database. The database is just going to be an in-memory database for this lab, and this will hold the database context so that we can use the other aspects of the application. Once we've defined the application DB context class, then I'm going to go into program.cs and make sure we can reference it. So in our program.cs, we're going to add a DB context singleton so that we can reference that singleton anywhere in the application. So here we're just going to call it user auth in-memory app as a part of adding that to our program. In step 2, you're going to create the registration class. And for that, we're going to create a new CS file in the models folder called registerviewmodel.cs. And this class just has 3 properties: an email property that's a string, a password property that's also a string, and then a confirm password property that's also a string type. So this will have all 3 properties here, and we're using the required attribute on the first 2, and then we're going to have a compare attribute on the last one. You'll notice on the last property, you're going to add this compare item, and essentially what this is going to look for is if 2 passwords in our field do not match, then it'll produce an error message for the user. And that's it. That's the lab.
In every application, users are assigned specific permissions that determine what they can access. In ASP.NET Identity, this controlled access is managed through user roles. In this video, we will explain the role-based access control system in ASP.NET Identity and explain how roles are assigned to users. Let's start by defining role-based access control and how it works. Role-based access control, or RBAC, is a control mechanism that restricts system access to authorized users based on their roles within an organization. RBAC assigns different roles to users within a system. This role determines what parts of an application they can access. For example, consider a school computer system. Teachers might be permitted to update grades, while students can only access their personal records. Let's examine what a particular role can control within an application. In ASP.NET Identity, the class Role Manager manages creating and assigning roles to users. Role Manager makes it easy to create roles like admin, user, or editor and assign them to different users. For example, in a CMS, the system uses roles to determine what each user can access. An admin has full control over the system with permissions to create, delete, and update user accounts. An editor can write and publish articles, and a user will be limited to read-only access to published articles. This role-based structure ensures that every user has the appropriate level of access based on their assigned responsibilities. Using Role Manager, you can create and manage these roles to decide who gets which permissions. Next, there's database storage. After creating roles, they are saved in the ASP.NET Roles table using IdentityDB context. The ASP.NET Roles table is specifically designed to track role information, and IdentityDB context ensures that role assignments and their related data are handled and saved correctly in the database. Let's consider an example of an application that displays how RBAC works. Think of an e-commerce site. Role Manager gives you the admin access to manage products, update prices, and all customer orders. It also includes key administrative tasks, such as creating user accounts and defining roles, ensuring efficient system management. An editor will be able to write item descriptions but not update prices. A user will only be able to browse products and make purchases. When an admin logs in, the system uses IdentityDB context to check the database for their assigned role. If the role is identified as admin, they are granted access to the admin dashboard, where they can manage products, prices, and customer orders. Additionally, admins can perform essential tasks like creating user accounts and assigning roles, ensuring seamless system management. When users log in, the system uses the IdentityDB context to verify their assigned role. After verification, they only get access to the shopping features like browsing products and making purchases. This role-based system keeps the application secure and ensures everyone only has access to what they need. In this video, you learned about the role-based access control system in ASP.NET Identity and how user roles are assigned. Understanding access controls in ASP.NET Identity is crucial in building secure applications. Access to information shapes the security and functionality of any app. With claims-based authorization in ASP.NET Identity, you gain the flexibility to assign precise access to users based on their unique attributes, creating a more secure and customized experience. In this video, we will explain how claims-based authorization works in ASP.NET Identity and how claims are assigned to users. Before we discuss claims-based authorization, we must first define what a claim is. Claims are name-value pairs that represent an attribute or characteristic of a user or entity. For example, imagine an amusement park that lets people into different areas based on a special wristband. This wristband contains information about you, like your name and age and what rides you're allowed to go on. These bits of information about you are like claims. For instance, the name-value pair for age could be age and a number value like 22. These are facts about you that the park uses to decide what you can do. With this understanding of claims, let's now define what claims-based authorization is. Claims-based authorization is a security model where access to resources or applications is determined by evaluating the claims associated with the user's identity. Unlike role-based authentication, RBAC, which relies on predefined roles, claims-based authorization offers more flexibility by allowing permissions based on multiple attributes. Let's explore claims-based authorization in more detail by discussing some of its key elements, starting with assigning claims. Claims are assigned using the User Manager class in ASP.NET Identity. Assigning claims is important because it allows us to specify what level of access a user should be assigned. For example, we could assign a claim to a user named Alex, who works in the IT department. You could assign Alex a claim like department:IT. Doing this would allow Alex to access IT-related resources in an app, like the IT support dashboard, which is available only to IT staff. Once claims are assigned, we need to understand how the system is storing claims in a database. In ASP.NET Identity, claims are stored in the database in the ASP.NET User Claims table. For instance, in our example, when Alex logs in after logging in, the system retrieves Alex's claims directly from the ASP.NET User Claims table. Because this claim is stored, Alex can continue accessing IT resources seamlessly without needing to request permissions again. Storing claims in the database ensures that permissions persist across logins, providing a smooth experience for users. This approach makes the app faster and more efficient, even when working with a large number of users. It also maintains consistency and security, especially in distributed systems running on multiple servers. Additionally, it simplifies permission updates. Changes are applied instantly during the next authentication, requiring no extra effort. Now that we have explored how claims are assigned and stored, we need to examine how authorization policies are used to control claims in specific system areas. Authorization policies are rules that help us decide who can access certain areas of a system. In ASP.NET Identity, these policies check the user's claims before allowing access to a particular area of a system. For example, when Alex tries to access a secure area like the server management page, the policy checks if Alex has the IT claim for department. If Alex does, access is granted. If not, the policy will block Alex from entering. In this video, you learned about how claims-based authorization works in ASP.NET Identity and how claims are assigned to users. By using claims, you can grant users access tailored to their specific responsibilities, ensuring precise and secure access control. While roles are effective for simple static scenarios, claims are essential for dynamic environments requiring detailed and adaptable access management. You've learned a lot about user roles and claims in ASP.NET Identity, and now it's time to put it all into action. In this video, we'll demonstrate how roles and claims management is implemented in ASP.NET applications using ASP.NET Identity. So to start out, we have a simple program here. I just created a new web app and I added a few new routes. We have this admin only and user claim check. And the idea here is this one will only be accessible to people with the admin role, and this one will only be available to people with the IT department claim. We will also create a couple of roles here. We'll create an admin and a user role. And then additionally, we've created some namespaces we've brought in here. So these are the packages we've brought in. You have Entity Framework Core, which is how we're handling the database and data management. We're also going to use an in-memory database, which is sort of a quick way to stub something like this out. It's not a full-fledged database. You would not want to use this in production, but it's much simpler than doing things like setting up the actual migrations that would be necessary to create the users and roles in a more formal database. Next up, we have ASP.NET Core Identity, which handles the user management. And then we have this identity.entity framework core package. And this is sort of the glue that connects together identity and entity framework core. And then finally, I've created a few requests here in this .http file that we can use to test these routes. And that is thanks to this handy REST client extension here. I'm a big fan of this. If you want to make these requests using curl or something like Postman, you are also more than welcome to do that. So heading back to program.cs. So the first thing we're going to do is we are going to add our database. So let's go builder.services.add DB context, and we will pass this an identity DB context right there. For simplicity, then we will pass some options use in memory database, and then we will pass that a string. So we'll call this auth demo DB. So that is how we set up our database. Next, let's go ahead and build identity. So let's go builder.services.add identity. And we will pass this identity user and identity role. And now if you wanted to create your own custom users and roles, you could use those here instead. But for the sake of this, let's just go ahead and use those built-in ones. .add entity framework stores. And this will be in that identity DB context. And now it is not finding these because we did not pull in that using statement. Let's see if it can auto do that for us. It's not working for me at the moment, so I will just come up here and say using Microsoft.ASP.NET and that should resolve that. Perfect. And so now we have our database, and now we have identity set up to create a table of users and a table of roles in that database. Next, let's go ahead and set up our authentication and authorization. So let's go builder.services.add authentication. Then let's go builder.services.add authorization builder, because we're going to do a couple things to this here in a bit. And with that, let's go ahead and start our application. So let's .NET watch down here, and that should kick us off. And now we are running. So I'm going to come over to my request here, and let's make sure I can get my root. And these two routes are not protected yet, so we are seeing the contents of them with the status 200 OK. Now we are going to see if we can change that. So the first thing I'm going to do is I am just going to add basic authorizations here. So I'm going to say require authorization. So this will require that a user is logged in and has a valid cookie to access these two routes. I will save that, and I will restart the server, and we are waiting for this to build. Now that that has built, let's come here and see if we can get our routes. And now we are getting a 404 not found. And now that is a bit of a weird behavior here because we really don't want a 404. This is a valid route, but they're unauthorized. And so really what we want to see here is a 401. Now, the reason we're seeing a 404 is because the default behavior here is that if a user tries to access a route they are not authenticated to get into, it will try to reroute them to a certain page. And in this case, that default is this route. So let's go app.map get, and this route is going to be, I believe it's /account/user. And we will say this is the user route just to show you that this is actually what's happening. I missed a comma there. So let's go ahead and save that and restart our server once again. So once again, if we come over here and we try our routes, we should get this OK. And we get a 404 and a 404 once again. So I am going to redo this. And so the issue we're running into here is I made that wrong. It is account.login, I actually believe. Let's try this one more time. We should be able to come here and make our requests. That's good. And now you see this is the user route, and this is the user route, and that's because I did not change that. And so this is the login route technically. So that's what's happening here. Now, this is the normal behavior you would want if you were just making a web application or a website. If a user goes to a page that they can't access to, you tell them, hey, go log in. For APIs, this isn't normally the behavior you want. You want them to get an unauthorized. So the issue we're running into with the 404 there again is that in a normal web page, you would redirect them to the login. In this case, we don't want to redirect them to another page. We just want to give them a 401. And the way we're going to do that is we're going to go builder.services.configure application cookie. And this will take a function that is passed in options. And then we'll say options.events.onRedirectLogin. So this event will be called anytime that a user is bounced from a route and sent to the login. So when this would happen, we are actually going to sort of overwrite this behavior. So the sort of default behavior here would be to context.response.redirect, and that will go to context.redirect URI. And so this will send them to that account/login route. And then we also want to return task.completed task. And so now this works. This basically replicates the existing behavior. So where we're going to change things is we're going to make a sort of split in our application. So let's say this is where context.request.path.starts with segments, and we'll say /API. So we're going to make a slight change to the way our APIs are set up. And we will also add a second behavior here where we will check for context.response.status code. And we want that to equal status codes dot, I believe, 200 OK. Then let's open this up. So just looking again, we have this options when events, when they get redirected to the login, we will check to see if it's an API route and that the status code hasn't otherwise been tampered with. Thus, it's still 200. If it is, we will go ahead and respond with a 401. Otherwise, we will just go ahead and redirect them as normal. So let's go ahead and test this. So if I hit this, we will see that we are getting a 200 there. And then our blogs, it's rerouting us to login. And then if I click these, I'm getting a 404. And that's because I changed the names of those routes. So let's try this one more time. Now, if I do admin only, now I'm getting a 401 and a user claim check, also 401. Now, that is what we should be getting. So this is excellent. So we now have our API is actually protecting these routes. And so the first thing we should do is we should give someone a way to log in. So we're going to sort of create a user in a bit of a hacky way. You wouldn't want to actually do this in production. So we'll start here by creating a couple of routes that you can think of these as sort of like administrative routes. You wouldn't want to just leave routes exposed like this. You would want to like protect them behind admin permissions. But for the sake of demonstration here, we'll just go ahead and do these the quick and dirty way. And so we will create some roles, and these need an async function. And this will pull in the role manager. We will call this role manager. I will go ahead and close this response so you can see what's going on here. Then let's go ahead and return results.OK. And let's say roles created successfully. And I missed that last parenthesis. And so how do we create roles here? So let's say for each var role in roles. So these are the two roles we listed above. We have admin and user. So let's create both of these roles. Let's say if, let's await role manager. So the role manager is what we are going to use to access these roles. And we'll say role exists async. And we will look for that role. So we will await for the role manager to see if that role exists. And if it does not, we will await role manager dot create async, and this will create the role. So let's say new identity role, and this will take in that role. So this will create all of the roles we need. And now I could demo what this does, but it's actually not going to be very exciting because all it's doing is creating a couple of entries in our database. All right, so now we have these roles. So the next thing let's do is let's go ahead and create a user that we can assign those roles to. So let's create another route here, and let's say /API/assign role map post. All right. And so what is this going to take in? Once again, it's going to be an async function. And this time we want a user manager, and that user manager is going to take in an identity user type to let it know what kind of users we're working with. We'll call this user manager. So now the first thing we need is a user. So let's say var new identity user, and we will give them a username, and let's call them test user at example.com, and let's give them the same email. So we will use their email as the username. So let's say test user at example.com. All right, so let's go ahead and create that user. So we created the object, but we actually need to add it to our identity. So let's say user manager dot create async, and then we'll pass in that user, and it's also going to want a password. So let's make a really terrible password here. Please never use that password, but it will work for the purposes of what we're doing here. And then let's also say user manager dot add to role async. And this will be the user, and we will add it the role admin. So we're creating the user, and then we are giving it a role all at once. And then finally, let's do something in the return here. So let's say return if is in role, and then we will use a ternary statement here. Then let's go ahead and var is in role to make sure that we actually added them to the role. So let's say await user manager dot is in role async, and then user and admin. Then return is if they are in the role and we successfully added them. Then results dot okay. Otherwise, we want to results dot bad request. Excellent. So now we have a way of creating a user and assigning them a role. Just to go over that again, we create this new object, which is an identity user. We use the user manager to create them asynchronously, give them a password, and then we use the user manager to add them roles, in this case, the admin role. We check to see if that role was successfully added. If it was, we return okay. If not, we give a bad request. And so we can actually work with this information now. If we restart our server, so we had API assign role and API create role. So let's create a couple of new routes down here. I'll actually create them right here at the top. So say /API/create role, then /API/assign role. And let's try our normal route. So we should be able to see admin only, unauthorized, unauthorized, and then blogs. Excellent. So those are all working as expected. Now let's try create role 404 not found. So the issue here is that is a post request, not a get. Both of these are post. Then the other thing, it looks like I did not save that. So let me go ahead and restart my server once again. Now, if we come over here, we should be able to run this, and we get a 200 there, and then we get a 200 here. So the roles were assigned, and then we created that user. So now you might be wondering, we've created some users, we've assigned them roles. Now, what do we do with that? Well, the first thing we need to do is we need to log them in. So let's create another little API route here. Again, this is not a route you would actually want in production, but it is good for us to test here. So we will call this /API/login. Now you could normally just have a route where users could go to log in, but we will create this special route that will just log in one particular user. And this will want a sign-in manager, and we will want an identity user there as that type, and we will call that sign-in manager, and then we will need a user manager, and again, that will take in the identity user type, and we will call this user manager. And now, how are we going to log that user in? So first, we need to grab that user. So we'll say await user manager dot find by email async, and then we will say test user at example.com. I should just copy this from above to make sure those are exactly the same. And so that will grab our user. Then we say if user equals null. So we'll first check if that user is not actually there. So if we tried to run this before we ran the previous two routes, this would cause us some issues. So let's go ahead and catch that case. We'll say results dot not found, and then we'll say user not found. And then we have await sign in manager dot sign in async, and that will need a user. And then let's say is persistent to flag whether the cookie should persist after the browser is closed. Let's say false. So to recap here, we are grabbing our user from the user manager. That's that user we create when we call this route. And if they don't exist, we're going to return this. And then if they do exist, let's return results. .ok. And let's say user signed. Big exclamation point there, because that will be a big moment. So let's go ahead and restart our server. And this is API/login. So let's create one more call here. And that's API/login. And so let's send a request, create the roles, assign the roles, and then log in. Now you can see here, we received this set cookie header. Now this is a special header that your browser will know to then set this cookie with this value. And so this is sort of the secret key that our application is going to send back to say, hey, I'm logged in, this is who I am. And so let's check again here. If I go to 530, you'll see we can get it. If I go to admin, we are unauthorized. User claim check, we are unauthorized. So let me do this login again. And then let's go ahead and grab this cookie, because what your browser would do normally is grab this cookie and then send it back as the cookie header. And so now if I run this code, we get back a 200 OK admin access only. So we have successfully logged this user in, got a cookie back, and then set a cookie along with this. Now, the reason I needed to set this manually is because I changed a setting here in my REST API settings, because normally it sort of behaves like a browser and it just holds on to those cookies for you. So as soon as a user has logged in, I can then run to any of those routes and it will automatically send those cookies along. So if we come in here and search for cookie, you can say, remember cookies for subsequent request. So then when we log in, it'll get that cookie and it will automatically send that for any request. But I find for testing, I would prefer to have that set off so I can sort of explicitly say when I do and don't want that. So if I try to run this route, I'm still unauthorized. And if I bring this cookie down, guess what's going to happen? I get a 200 OK. And again, that is because these both don't actually have any particular claim or role required of them. So let's go ahead and change that. So let's create some policies. So we are going to add our policies on our authorization builder. So I will come down here and I will say .add policy. Now the policy is going to have a name. We'll call this one admin. And then this will take in a policy. And then we'll say policy.require. Let's do a role in this case. And let's say admin. So this policy requires that the user has an admin role. And then while we're at it, let's go ahead and make another policy here. Let's say add policy. And this time we will call this IT department. And this time, rather than using a role, we will say policy.require claim. We'll say department. And that will have a value of IT. So this claim is the department claim, and that has a value of IT. And so our user already has the admin role, but we weren't actually checking for it because we were just checking to see if we had an authorized user. So they just needed to have a cookie that says they had logged in. There was no particular permission required. So now if I change this to say admin, we are now requiring the admin policy, which in this case says that we require the admin role. And if we come down here, we can say we want this one to require the IT department. And again, those are coming from admin and ID department here. IT department, sorry. And so now these have specific requirements of those users' cookies to log on. So let's go ahead and save this one more time. Let's restart and let's go see what behavior we get now. So I'm going to come up to my requests. So let's go ahead and run these again. So we need to create a role, assign the role, and then do this API login once again. I will grab this cookie and we will come down and we will replace this cookie with our new cookie. And let's see what we get here. So before we were able to access all of these routes, let's see what we can do now. So the admin only, I can still access. This user claim, I cannot. And that's because our user does not have that claim. And they can't access blogs because we're not sending the cookie. But if we grab this cookie and attach that down here, we can now access those blogs. And so finally, let's go ahead and add a claim to our user, and we will add a new route to do that. And so we'll call this /API/add claim. And this will be similar, but we will just need the user manager here. And then once again, we are going to want our user. And if the user does not exist, we will return that result.not found. And so this time, instead of adding a role, we are going to say await user manager add claim async. And so we will do that on the user, and then we will say new claim, say department and IT. And this claim object was coming from our, I believe it's system.security.claims. All right, so this time let's go ahead and check if they have that claim. So let's say var claims equals await user manager dot get claims sync, pass in user there. And once again, that's lowercase u user manager. And then let's say var has IT claim. That's claims dot any c dot type equals department and c.value IT. So this will check to see if any of their claims have the type department and the value IT. And finally, if they do have their IT claim, we will go ahead and results.OK. And if not, once again, we'll results.bad request. Excellent. Then I will go ahead and save this. And then let's add that one more here. Let's add that claim. So API/add claim. Then let's restart our server one more time. Then we will create the roles, assign the roles, add the claims, log in, grab this cookie once again. We will use it in each of these three routes. And this time we should see that we are able to get in. So we can access there, and let's go ahead and see we can access the claim now, and we can still access our blogs route. So we have now implemented a role-based policy, a claims-based policy, and we have these three routes that we can get to depending on whether or not a logged in user has the roles or claims. I know this is a lot. Hopefully this gives you a great sort of example of how you can start building up authentication systems, and this will sort of be the framework for the rest of building applications in this course.
In this lab, we're going to implement roles and claims management in an ASP.NET application using ASP.NET Identity. So in step one, we're going to configure the roles in the core application, and we're going to do that in program.cs. So we're going to add all of this code right to the area of the program that runs when the application starts. The first thing we're going to do is create a role manager object with the role manager identity role type, and we're going to use the ASP.NET Core Identity library to do that. And in that library, we're going to use the services.getService method to create that role manager object. Once the role manager object is created, then we're going to use create async to create new roles, admin and user, if they don't exist. The first thing we do is check and see if they exist in the role manager object. If they don't exist, we're going to create them new, and we'll do that for both the admin and the user object. In step two, we're going to assign claims to the roles. So The first thing we're going to do here is create a claim object using the claim type, and we're going to use the permission and manage employee records attributes. We're going to send that to that claims method as we create this object. And then after that, we're going to try to find a specific role in the role manager object. In this case, we're going to find by the name HR. And if we find that role in the role manager object, we're going to add the claim that's identified in claims, which is permissions and manage employee records. So that's the claim that we're adding to that specific role in role manager. We do that using the claim object. And then finally in step 3, we're going to add our route in a route controller.cs file. This will allow us to interact with the roles in the role manager using get, post, and delete methods. So in the first item, we're going to use the get method to authorize the roles as HR. The first one will just return all the employee records using that specific HR role to authorize the request. So the get all will return all the employee records, and it will be authorized if the role is in that HR type. The next thing we're going to do is add a post method, and this will allow us to add employees. And here the policy that has to be in place is manage employee records. This post request will only be authorized if the requester has part of the policy manage employee records. And it will add employee and then return OK that the employee record was added. In this code, it's not actually adding anything in a database, but it's just showing where you would put the code to add employee records using that specific policy. And then similarly, the last one we'll add is the delete method. This is passing in the ID for a specific employee. And the policy has to be also manage employee records. So if the requester is authorized to use that policy, then the remove employee method will run. And then we, of course, add code to remove the employee and then return the OK status so that the calling application knows that the employee was deleted. And those are the steps of this lab to add roles and claims to an ASP.NET application.
Do you ever wonder how you can stay securely connected to an online service without logging in repeatedly? Token-based authentication makes it possible, ensuring both convenience and security by allowing services to verify your identity with reusable tokens instead of repeated logins. In this video, we will explain the concept of token-based authentication and its role in securing APIs. To understand how token-based authentication works, let's first define what a token is. A token is a small piece of data that serves as a credential to verify a user's identity and access rights within a system or application. This token is typically encrypted or digitally signed to enhance security and ensure its authenticity and integrity. Now that we understand what tokens are, let's explore what token-based authentication is. Token-based authentication is a security method in which a user receives a token after logging in to authorize additional transactions. With each subsequent request, the token is sent to verify the user's identity. For example, when you log into a social media platform, you don't need to enter your credentials each time you post, like, or comment. That's because a token has been issued to manage authorization for each action. Now let's explore the different elements of token-based authentication. Let's start by exploring the most common type of token, JSON Web Tokens. JSON Web Tokens, or JWTs, are a specific type of token that securely stores user information in a compact format called a JSON object. It typically contains encoded details like the user's ID and permissions. JWTs are signed to ensure the data's authenticity and integrity and prevents unauthorized modifications. JWTs are widely used because they are compact and securely carry user information. Because of this, they're commonly used for authentication and authorization in web applications. For example, imagine a student logged in to start a course. The platform issues a token to specify that this user is a student with access to content, discussions, and assignment submissions. As the student navigates to different sections of the course, the platform reads the token to confirm they have the appropriate permissions without additional logins. If the student tries to access areas restricted to teachers, the platform will automatically deny access based on the token's role data. Since tokens enable seamless and secure access, they are central to stateless authentication. Stateless authentication is a way of verifying users without requiring the server to maintain any session data. Instead, each user request includes a token that confirms the user's identity, allowing the server to manage each request independently. This approach makes systems faster and more efficient. Consider, for example, accessing your bank account online. Each time you perform an action, like accessing your balance or transferring funds, the server checks the token sent with your request, allowing it to authenticate you without tracking or storing any session data. This stateless approach keeps the system both efficient and secure. With an understanding of stateless authentication, we can now explore how tokens protect APIs. Tokens secure API endpoints by ensuring that only authenticated users can access them. The API validates each token to confirm the user's identity and permissions. For example, in a fitness app, only a valid token grants users access to their personal workout history, preventing unauthorized individuals from accessing data that belongs to that user. Now that you understand why you might want to use token-based authentication, let's explore how you would implement it. The process begins when the user logs in with their credentials, starting the authentication process. After a successful login, the server issues a token, often a JWT, containing essential information about the user's identity and permissions. The token is included in each subsequent request, allowing the server to identify the user's identity and permissions. The server then checks the token to ensure it's valid and authentic. If the token is valid, the request proceeds. Otherwise, access is denied. If the token passes validation, the user is granted access to the resource. Typically, tokens are stored in the client's browser, either in a cookie for security or local storage. In this video, you learned about the concept of token-based authentication and its role in securing APIs. By verifying users with the reusable tokens instead of repeated logins, token-based authentication helps to protect applications. Cookies are largely considered the gold standard of working with backend security. They are incredibly powerful when working with browser environments and any front end that can support cookies. But not all front ends can support cookies, and sometimes you need to work with some kind of a third-party service that can't issue cookies for you, and in those situations you often have to work with security tokens or session tokens. Now, one of the most common types of tokens is JWTs. And now, .NET doesn't have built-in support for issuing JWTs. You can implement it into an API if you want. It does have its own proprietary session token that performs a lot like a JWT. So I find them to be a really nice sort of introduction for working with session tokens, because everything you're going to learn here will apply to JWTs in the future when we delve a little bit more into them. So in this application here, we have identity setup, we have a couple of policies, we've got roles, we've got users, we have these routes that are secured behind different policies. We have an ability for users to log out. We can also add roles and add claims to users. And now getting sessions is actually relatively straightforward because we are set up out of the box using identity to generate sessions. Let's go ahead and start our application. And if we come over to our flow here, we can get our root route without any kind of authentication, but we cannot get to this secure route. So let's go ahead and register a user. And now we could sign in and we can get back a cookie. So this sets a cookie in our editor here, sort of like it would a browser. We are automatically storing this cookie and sending it with all future requests to provide our login. It all sort of happens behind the scenes. We don't have to do anything with this. I can just hit this secure route and all of a sudden this works. But I want to go ahead and log this user out and show you how a session token would work. So I have this flag here, use cookies equal true. If I turn this to false, we will see a difference when we log in. So now you're seeing instead of a cookie, we are getting this payload with an access token. Now this is a session token. So I have now logged in. You would think I can come up here and I can access this secure route, but I cannot because like I mentioned, tokens do not act exactly like cookies. They're not automatically stored by the client. You have to manually implement how you will use these. And there's two tokens here. We have our access token and our refresh token, and it expires in here. We'll get to why these are a little bit later, but know that this is the payload you're going to get. So how do we use this token? Well, this is a bearer token. And the way we use bearer tokens is I add in a header that is an authorization header. And then I add the word bearer followed by a space followed by our token. And so now I can send this request and this is now able to access it. If I goof up that token, delete a couple of characters, I am now unauthorized. And so I could use either a token or a cookie to access this API, but I can change which one I get when I use my login here. And so tokens, as I mentioned, are handled a bit differently here. Cookies are considered sort of the default you want to use if you're an environment that can make use of cookies. You also have this option of using tokens. You could also use an external JWT provider to provide these tokens for you, and we'll talk about that a bit later, and you need to do a few more steps to be able to take those JWTs instead of the built-in identity session tokens, but know that they're used very similarly. One of the things about session tokens is we don't really have a way to revoke them. If I log this user out, I can just continue to use this token. I still have the token. It's not like the cookie where we can overwrite that cookie with a blank value. So one of the key things about working with tokens is you typically don't want them to last for very long. This means that if someone was to get a hold of this client's token, they would be able to access your application even though they shouldn't be able to. But you're limiting the amount of time that they have access to the application. It's not perfect, but it is sort of one of the standards of setting security this way. And so when we requested our tokens, one of the things you saw here is we have this expires in. That means we expire in, I believe this is 1 hour. These are probably seconds. So this is 3,600 seconds or 1 hour. And so that's why we get this refresh token. The refresh token gives us a way that we can use this token, store it very securely, and then periodically say, hey, I need a new token. I need a new token. I need a new token. And we just need to do that before our token expires. And now that refresh route we would use to refresh that token is one of the routes that we get from identities. So let's say we want to refresh a token. We would make a post request to our API, and this would go to the refresh route. So the way I'm going to refresh that token is I am going to hit this refresh route. This is automatically created by identity, and this will need a payload, so we'll give it a content type of application, JSON. And then we will give this a payload. And what is in that payload? Well, it takes in a refresh token. And that refresh token, if we make another request here, we can take this token. And notice this isn't being passed through the headers, this is being passed through the payload. Now make sure to put that in double quotes, and then we can hit send, and now we will get back a new token, and I can keep refreshing that, and I will keep getting back new tokens. We could then grab this token and use it just like we did our previous token. But notice that this does not invalidate our previous token. It just means that we now have a new token. So that is how you refresh a token with one of these session tokens. And that's pretty much all you need to know to set up session tokens in .NET. All you have to do is change the way you're logging in to say you want to use a token instead of a cookie, and then create a method on your client or front end to pass that token along to the authorization header as a bearer token. And remember that you cannot log a user out of a token, so you need to have security measures in place to invalidate that token periodically, and then you can allow users to refresh that token to get new tokens so that they don't have to constantly log back in.
In this lab, we're going to implement token-based authentication using ASP.NET Identity in an ASP.NET application. So I have an ASP.NET web application here, and we're going to begin by looking at the account controller.cs file in the controllers folder. Now we're going to assume that there's users and roles already added to this application and just use them in these API endpoints in order to set user claims and retrieve them. The first thing we're going to do in step 1 is to assign roles to a user. And I have a post route here with a task called register. And we're going to send in a view model to accomplish the task. And the first thing we're going to do is create a new variable called user. And it's going to be a new identity user. And we're going to set the username to testuser@example.com and the email to the same, testuser@example.com. Many systems use the email as the username. We'll create that user. And then we're going to assign the admin role to the user. So the first thing we do is call create async to create the user in the system. And then we'll go ahead and call add to role async. And here we're going to assign this user the admin role in this example. Now, in a real world example, we would pass in a username and email. But in this case, we're just going to create this as a hard-coded example. Create this individual user and then assign the role admin. In step 2, we're going to add claims to this user, and that's another post endpoint. So this one is called set claim, and here we're going to look up the user. So once the user's been added, in order to add a claim, we're going to fill the user variable by looking up that user, and here again it's testuser@example.com. And then we're going to use the user manager object in the add claim async method. For the first variable, we're going to pass in the user, which we just looked up. And then we're going to add a new claim, and it's going to be the department, which in the department assignment is HR. So this user will get that claim added to them using this endpoint. And then in step 3, we're going to test the claims. So that's the final endpoint here, the get endpoint. And we're just calling this one get claim. And again, in the first line, we look up the user, find name by name async. And then we're going to get the claims. We're going to pass in the user that we just looked up and then fill the claims variable by using that user manager object again and calling the get claims async. Now we're going to check and see if the user does have the claim. So this is a Boolean value. It's going to be yes, no, true, false. Use this claims.any method to look up the claim type of department and the claim value of HR. So if the user has the claim, then we write out to the console access granted. Otherwise, we write access denied. So this allows us to look up the user by a specific name and then determine whether they have the right claim in order to access the resource that we need. So using these 3 endpoints, we can essentially create a user in the system, assign a claim to that user, and then look up whether that user does have that claim to access any resource that we want to give them access to.
Users expect quick and secure access to apps, but managing multiple accounts can be challenging. Using ASP.NET Identity, you can offer a secure login experience using credentials for services your users already trust to create a better experience for your users. In this video, we will identify the benefits and uses of external authentication providers and their role in ASP.NET Identity. Let's first define what external authentication providers are. External authentication providers are third-party services or systems that manage the authentication process for an application, verifying a user's identity and using secure protocols. By leveraging trusted platforms, applications can focus on delivering value while ensuring a secure, user-friendly experience. Now that we know what external authentication providers are, let's explore some of their benefits. First, they simplify logins by allowing users to log in using existing accounts, like Microsoft or Facebook accounts. For example, many apps provide a sign in with Microsoft button that allows users to bypass the need to create a new password. Another benefit is enhanced security. External providers manage password security and can offer additional features like two-factor authentication. For instance, when logging in with a Microsoft account, you may be asked to verify your identity through a phone notification or an email code. A third benefit is increased trust. Users are more likely to trust apps that let them sign in using well-known providers. We've covered the benefits of external providers, but how exactly do they manage the authentication process? Let's first discuss OAuth 2.0 and how tokens are used for secure authentication. OAuth 2.0 is an authorization protocol that allows applications to grant limited access to users through external providers. This protocol uses secure tokens rather than requiring users to share their credentials directly. For example, when you log into an app with your Microsoft account, OAuth 2.0 facilitates the process by generating a token that confirms your identity. This token acts as a digital pass, allowing the app to verify who you are without needing to store or access your password, thus enhancing security, protecting your credentials. While OAuth 2.0 manages authorization, how do we verify the user's identity? Well, that's where OpenID Connect comes in. OpenID Connect, or OIDC, is an identity layer built on top of OAuth 2.0 protocol and is designed to authenticate a user's identity and provide information or claims about the user to the application. With OpenID Connect, when someone logs in to your app using a Microsoft account, the protocol verifies this person is indeed who they claim to be, adding an additional layer of security to ensure accurate identification. For example, when you use a website sign in with Microsoft feature, OpenID Connect ensures that Microsoft verifies your identity, meaning the website doesn't need to store your password. OAuth 2.0 manages what users are allowed to do, while OpenID Connect confirms who they are. Together, they ensure both identity verification and access permissions are securely managed. In this video, you learned about the benefits and uses of external authentication providers and their role in ASP.NET identity. By leveraging external authentication providers, you can offer a seamless login experience that users trust while enhancing your app's security. Up until this point, we've been using identity to handle authentication and authorization in our applications. But what if we wanted to use a third party like Microsoft or Google so that someone could use their existing accounts to authenticate, and those services could then tell our application, hey, this user is logged in, go ahead and let them into your application? Well, we can absolutely do that using .NET. In this video, I will explain how external authentication providers are integrated into an ASP.NET application using OAuth 2.0. So in this video, we're going to walk through the process of integrating Google. It's one of the most common external login providers for applications across the web in general. So we have a really simple app starting here. We have the root route, and we have this route down here that we want to secure. Nothing else going on. Now notice we're not going to implement identity here, so we don't need a database. We don't need the identity services. We don't need identity API endpoints, but we do need authentication and authorization. So let's come above our app and do builder.services.add authorization. And right before that, let me also do authentication. Add authentication. So now we have authentication and authorization, but we need to modify these to use Google. So the first thing I am going to do here is come into our authentication, and I am going to pass in a function that takes in some options, and I am going to set a couple of new options there. I am going to say options.default scheme, and I will set that to, let's do cookie authentication. Defaults, I believe that's what I want, then authentication scheme. So we are setting that to cookie authentication defaults.authentication scheme. And then next I will do options.default challenge scheme, and this is where I will set it up to use Google. So I will say Google defaults.authentication scheme. And now these Google defaults are not something that comes automatically, so we need to add that package. So let's say .NET add package. This will be Microsoft.ASP.NET Core.authentication.google We will add this package by going .NET add package, and this will be Microsoft ASP netcore.authentication.google. Then I will go back and correct the word package. And it looks like everything installed correctly there. Now we should be able to fix this. We can do quick fix, and we will just pull in that using, and now that works. And then next up, because our default authentication scheme is cookies, we will want to add cookie, and it needs this because we cannot have an external provider as our default provider here. So we will also add in cookie auth as well. And then let's add Google. And this is where the magic happens, adding the Google settings. So let's again pass in some options. And so this is where we will need specific information from our Google account to set up this kind of authentication. So I am going to need options.clientID, and this value will get set here in a second. I will put in just a blank string for the moment. And then we will need options.clientSecret, and again, a blank string. So these are some values that you'll get from Google that you want to keep very secret, because if you expose these, sort of like your secrets in other places, someone can exploit your application and sort of pretend like they're you. So these should be kept very, very secret. Now, there's a bunch of different ways to do this. You can use environment variables. You can use user settings. For this demonstration, I am going to go ahead and set these up in my app settings. You could add this to your version control system to ignore this file to make sure this never gets committed to code, so that the code in your repository and the secrets are never in the same place. Okay, so then the secrets we're going to want here, let's go ahead and call this authorization. And now you can sort of set these up however you want. I find this is a relatively clean way to do it. And we will say this is Google. And then let's go ahead and have that client ID. And then we will also want the client secret. Now, for now, I am just going to paste in values because I've already generated these in the Google console, but we will walk through later how to actually get these values. And again, you really, really, really want to keep these secret. So I am going to grab the client ID here, and I am going to grab the client secret here. Now, know that I am going to delete these credentials from my account after this, so you will want to use your own credentials. These will not work for you. Now I'm going to go ahead and save these settings. And so those settings will be passed in. We can say builder.configuration, and then we need the path to them. I believe that was authorization. And then we said Google, and I believe this one was client ID. And then let's also come down here. And this one was the same, except it was client secret. Now this is giving me squigglies because it's possible that these aren't set. In this case, I know that they are set and should always be set. It would be best practice to come here and say, do something like a throw new error if that doesn't exist. But we will go ahead and hold off on that for now. So we now have our client ID, our client secret. We've integrated authentication. We don't need to do anything special for our authorization. So let's go ahead and take our app for a spin. Say .NET WAT. All right, so it looks like I'm getting an error here. So I will go back, and it looks like my app settings, I misspelled that. So I will save that, and I will go ahead and restart that and see if that fixed the issue. All right, and looking once again, it looks like we have one more error. That's it right there. I have an extra S, authorization.google.clientID, authorization Google client secret. Third time's a charm, right? So I will save this, then I will restart the application. Now, one more time, I will come over here, and this time it worked. So now I have those values matching up correctly. And so I can come to my root route, no problem. It does not require authentication, but if I try to go to secure, this needs authentication. So if I click here now, it will reroute me to sign in through Google. And then if I go ahead and sign in, I am now able to access this secure route. So that is how you use an external authentication service like Google to log in to your applications in .NET. So now I showed you before that we had this client ID and client secret. So let's go ahead and walk through the process of how we get those values. So the first thing you're going to want to do to create these values is you're going to go to console.cloud.google.com/APIs. And that will bring you here. you are going to click Credentials to create some new credentials. You'll see your new credentials here under this OAuth 2.0 client IDs. So let's create some new credentials. Now, the first thing it's going to say is we need to configure our consent screen. So we are going to use this externally. You will go ahead and click Create. And now we will give our app a name. So we'll call it My Test App. And the user support email, we will use this same email. Then we could upload a logo, domain. Then once again, let's do my email. Now we can save and continue. We will go ahead and leave the default scopes here. And once again, save and continue. And then I will go ahead and add a user here, and that will be tyler@aptly.co, because this will be in testing. Then save and continue. And now we have all of the information we need for that consent screen. So we can go back to the dashboard, again, go to our credentials, and now we can create a new credential, OAuth client ID, and this application will be a web application in this case. And then we will just leave this default web client 1. And now we have a couple of options here. We can add JavaScript origins and we can add redirect URIs. See, it says here for use with requests from a browser. Our application is not going to be making requests from a browser. It's making them from my backend. So we want these redirect URIs. So these are for users with requests from a web server. So let's go ahead and add a couple of URIs here. Now these need to be the address that your application is going to be making the request from. Now, there are 2 redirect URIs I'm going to want to add here, depending on whether or not we're using HTTP or HTTP secure. So the first one is going to be our app. And then this is a setting that is sort of different for each of the external providers. So this one I will say signin.google. Now, this redirect URI is a path that you can actually set in your application, but this is the default our .NET application is going to use. So let's go ahead and use this. And then I will add one more, which will be the exact same, except I want HTTPS in case we want to test this running securely. So let's go ahead and create. And so now I have these credentials. We have this client ID and client secret. We can come back to our application and we can plug them into the client ID and client secret here. And this should now work with your new credentials. And with that, we have now used an external authentication provider in ASP.NET using OAuth 2.0, and we can now let users log in with Google to our .NET application.
In this lab, we're going to implement external authentication providers in ASP.NET Identity using OAuth 2.0. In step 1, we're going to simply set up the application. I've got a simple ASP.NET web application here. And in program.cs, I'm adding the line builder.services.add controllers. And that will allow the app to find and discover any controllers that we add to the application. In step 2, we're going to configure Google Client and Authentication flow. You can see at the top of the file, I have google.apis.auth and google.apis.util. Those libraries I've already added. I've pre-added those to the application, so now we can use those libraries for the rest of the lab. So the first thing we do here is to create a new variable called client secrets, and we're just going to use that variable to store our secrets that we have in our configuration file. So we have a client ID and a client secret, and those are in a separate file. And then we pull those in and store them in client ID and client secrets so that we can use them when we make our authentication request from Google. And then for the scopes, we're going to set this to googleapis.com/auth/userinfo.profile. This is a variable that we'll use when we make that authorization claim. And we want to use userinfo.profile for that scopes variable. Then we're going to set the data store path. The data store is where the credential information that Google provides is stored on the local device. And so we're going to set that to the special folder.application data. And that just looks for on the system a particular folder named application data or whatever that variable is set to for the operating system. And it will use that to store any of the authorization and credential information.
And then finally, we want to create a credential variable. This is where we authorize the request using Google Web Authorization Broker, which is a part of one of those libraries that we added earlier. And we're passing in client secrets, the scopes variable. We're going to pass in the value user as a string. And then we want to set the cancellation token to none on this credential. And then we also pass in our data store path so that Google knows where to store the credential information when it returns. Finally, in step 3, we're going to create the login endpoint, and this is just a route this is an API route, and you can see it's at /login here. When we hit this endpoint, we're going to write out the authentication as a response, and we're going to use the write async authentication string to determine where that response is written to. So the value there is authentication. And that's how we can implement in a very simple way external authentication provider using Google in this case to get an authentication from Google, and then use that in an endpoint in our app.
Securing APIs with ASP.NET Identity involves mastering a range of techniques to build secure and scalable applications. Here's what we covered in this module. We began by introducing ASP.NET Identity, highlighting its vital role in managing authentication and authorization for modern applications. Next, you explored the process of user registration and authentication, learning how to implement secure workflows that protect user access effectively. Then, we examined how to manage user roles and claims, enabling precise control over application permissions and ensuring robust access management. After that, we learned about token-based authentication, focusing on its implementation for secure, stateless communication between clients and APIs. And finally, you discovered how to integrate external authentication providers, allowing seamless and secure user access through platforms like Google and Microsoft. Congratulations on completing securing APIs with ASP.NET Identity. You've taken an essential step in building secure, reliable, and user-friendly applications. Welcome to Role-Based Access Control and JWT Authentication. In this module, you'll learn to manage application access with Role-Based Access Control, or RBAC, and JSON Web Tokens, or JWTs. From understanding RBAC fundamentals to implementing JWT authentication and securing APIs, you'll gain the skills to build robust, secure systems and apply best practices for processing your endpoints. We will begin by exploring Role-Based Access Control, understanding its importance in managing user permissions and enforcing security policies. Next, we'll examine the structure and purpose of a JSON Web Token and learn how they enable secure communications between clients and APIs. Then, we'll dive into implementing JWT authentication in ASP.NET Core, focusing on the practical steps to configure and use JWTs for your application. After that, we'll explore how to secure API endpoints using JWTs, ensuring that only authorized users can access sensitive resources. Finally, we'll wrap up with a discussion of best practices for implementing JWT authentication, which will help you create secure and efficient systems. Mastering role-based access control and JWT authentication is essential for safeguarding your applications and maintaining trust with your users. Let's get started with role-based access control and JWT authentication. Controlling access to resources is essential in any system, from small teams to large organizations. Role-based access control, or RBAC, offers efficient management of permissions, ensuring that users have appropriate access based on their roles. In this video, we will define role-based access control and its role in managing permissions and resources in an application. Let's begin by defining what role-based access control is and how it helps manage access to resources. RBAC is a security model for restricting access to systems, data, or resources based on the roles of individual users within an organization. When using RBAC, instead of assigning individual permissions to each user, you assign users to roles, such as admin or users, each with predetermined permissions. This approach simplifies access management, especially when handling many users. Now that we understand how RBAC works, let's explore the key concepts of how roles are used to assign permissions to an application. Using RBAC, users are assigned roles that define what they can do within a system. Instead of assigning permissions individually to every user, you group users with similar responsibilities into roles like admin or employee and assign permissions to that role level. When a new user joins, you simply assign them the appropriate role, like admin or author, and they automatically receive the correct permissions, ensuring consistency and preventing misassignments. Another key concept to help understand RBAC is JSON Web Tokens. Recall that a JSON Web Token, or JWT, is a compact secure token exchanged between a server and a user to verify identity. In role-based access control, JWTs securely transmit user roles and permissions after authentication. Upon login, the server generates a signed JWT containing the user's ID, roles, and other metadata. This token is stored on the client side and included in subsequent requests from the user. Utilizing JWTs in role-based access control makes the system both faster and more secure. Now let's compare RBAC to claims-based access control. You will find that claims-based access offers more specific control. Using claims, you can have more granular permissions within a system by assigning individual permissions to users rather than grouping them into roles using RBAC. For instance, in an HR application, one user might have a claim allowing them to edit personal information, while another user might only have a claim to view reports. With an RBAC, users are assigned roles that already contain permissions, making them more straightforward to manage but less flexible than claims. Finally, let's discuss how Role Manager in ASP.NET Core helps manage roles and assign them to users. Recall that Role Manager is a class in ASP.NET Core that helps create and manage roles. When a user logs in to ASP.NET Core, it uses Role Manager to assign their role and creates a JWT that includes this role. For example, if a new user is assigned the admin role through Role Manager, they immediately receive all the permissions linked to that role. Their JWT token will contain the admin role, allowing them to manage the system as soon as they log in. This process saves time and reduces the risk of permission errors. Now that we have explored the key concepts of RBAC, let's examine a few common user roles in a system. Let's start with the admin role. Admins need full control over the system, including the ability to manage products, orders, and users. When an admin logs in, their JWT token includes their admin role, giving them access to all essential features. Next, we have the manager role. Managers are responsible for overseeing operations and ensuring smooth workflows. To monitor and manage activities effectively, they can view product lists and access order lists. When a manager logs in, their JWT token includes their manager role, granting them elevated permissions without full admin access. And finally, there's the customer role. Customers only need access to browse the product list and place orders. When a customer logs in, they have a JWT token that limits them to browsing and purchasing products. In this video, you learned about role-based access control and its role in managing permissions and resources in an application. Systems can manage access efficiently by grouping permissions into roles and securely verifying them through JWT tokens, reducing risk and streamlining operations. JSON Web Tokens provide a powerful way to protect sensitive information as it moves between the client and a server, ensuring that only the right people have access. In this video, we will explain the structure and uses of JSON Web Tokens in securely transmitting data. Recall that JSON Web Tokens, or JWTs, are a specific type of token that securely stores user information in a compact form, often as JSON objects. we're going to build on this understanding by exploring some key concepts of JWTs, beginning with their structure. Let's begin with the JWT header. The header contains information about the type of token and the algorithm used to sign it. For example, if the header specifies a commonly used algorithm named HS256, the system knows it should use the HMAC SHA-256 algorithm to verify the token. This is how the system identifies which method to use to validate the token's authenticity. Next, let's explore the part of the JWT structure that we call the payload. The payload holds the claims or data being transmitted and could include details like the user's ID or their roles in the application. For example, if the payload contains a string that includes John Doe admin, the server knows this is the user John Doe with the administrative or admin privileges. This makes it easy for the server to determine who the user is and what they can do based on the payload data. To further secure JWTs, they often include a special EXP claim specifying the expiration time. This claim ensures the token is valid only for a limited duration. Once the token expires, the server rejects it, even if the signature is valid. Another part of a JWT is its signature. The signature is created by encoding the header and payload and combining them with a secret key. For example, if someone alters the payload trying to change their role to admin, the signature won't match when the server checks it, and the token will be rejected. This ensures the integrity of the information transmitted. With this understanding of JWT structure, let's explore another key concept of JWTs, which is how they are used in web applications to manage user authentication and authorization. JWTs are central to authentication and authorization. For example, after a user successfully logs in, a JWT containing their identity and role is generated. If the JWT says the user is an admin, the application allows them to access administrative features like managing users. Finally, to keep JWTs secure, they are signed and verified. When a JWT is created, it's essential to ensure that no one can tamper with this data. And this is why JWTs are signed to lock the information securely. Once signed, it's verified by checking the signature key to determine if it can trust the token. For example, after a user logs in, the server generates a JWT, signs it with a secure key, and sends it to the client. Later, when the client makes a request with this JWT, the server can verify it by checking that signature. If the signature matches, the server knows the JWT hasn't been altered and can trust the token. Now let's deepen our understanding of JWTs by exploring a typical JWT workflow. First, when a user logs in, they send their credentials, like a username and password, to the server for authentication. Once their credentials have been verified, the server generates a JWT. This token includes claims like the user's ID, role, and expiration. And it is signed with a secret key to prevent tampering. Next, the signed token is transmitted back to the client as proof of authentication. The client stores this token securely, often in local storage or cookies, and includes it in every request to access protected resources. Finally, when the client sends a request with the JWT, the server verifies that signature using the same secret key. If the signature is valid, the token hasn't expired, then the server grants access based on the user's roles and claims. In this video, you learned about the structure and uses of JSON Web Tokens for securely transmitting data. By understanding their structure and implementing best practices, you can ensure both data integrity and user trust in your systems. JWTs are one of the gold standards for sending stateless, tokenized information around the internet to support authentication. And now, what actually is a JWT? In this video, we're going to describe the creation and decoding of JWTs in an ASP.NET Core application. Now, I'm going to take a step back from the code here and show you a little tool called jwt.io. It's this really handy website that lets you generate JWTs from raw data and sort of play with the data going back and forth. We're not actually going to hop in code in this video, but I want to show you what a JWT looks like, how it's made, and then we'll talk a little bit about how it's used later directly in .NET code. So we're going to see three pieces of information here on the right. See, we have a header, a payload, and this verification signature. Now this is a JSON object, this is a JSON object, and this is a special encoded signature here. This is actually how we sign our tokens. But let's take a step back and let's actually talk about the header and the payload. So you see these two periods here in the token, and they are what separates the different sections. You can see the colors coordinate here on the left to their portion on the right. And if for some reason there's problems with those colors, this first portion is the header, this second portion is the payload, and this third portion is the signature. Now you're looking at this thinking, I can't read this. This is encrypted. Well, it's actually not. At least the header and payload aren't. The header and payload are simply URL encoded using base64 URL encoding. Now it's just a way of turning this data into something that can more safely be transported as text in all the different parts of the internet, because there's certain characters that can be problematic in text if you're using different URL encodings. So we base64 encode them to make this safer to transport around the internet. It doesn't make it more secure, it just makes it less likely to be interpreted incorrectly when transmitted over various means. And so I want to show you a little bit how that works. So if I take this data right here and I use this little online tool and paste the data in, all we're doing is taking this data, getting rid of the spaces, and I will show you what this looks like if we URL encode it. Now notice there's no secret key here. We're not encrypting this. We are just changing the way this data is represented. And I hit this button, and here you see this is our base 64 URL encoded version of that data. It starts with EYJ and ends with CJ9. If we come over here, you'll see EYJ and CJ9. So this is the same piece of text that was generated over here. So if you wanted to get the JSON version of this, you would just reverse this base64 URL encoding. And if you wanted to encode it, you just do the opposite. The same is true of the payload. So these are just encoded data when they are in the token. This is the actual JWT. Now the third part of this token is where the real magic comes in. This is the signature. So the URL encoded data could be ferried around the internet. We can just send it in a header, we can send it in a URL. That's sort of the purpose of that URL encoding. But it doesn't make it secure. It's this signature that makes it secure. And so you could imagine maybe I would just use a secret password. And my server that was issuing these JWTs would attach that secret password to the end of every one of these messages. And then when my server got them, if it had the right secret password, we would know that this data is correct. Well, the problem there is if someone got a hold of this, they could manipulate this data. And they could add in extra things to the payload that weren't really supposed to be there. The magic of this signature is that actually invalidates the current signature. You see, the signature is created using a function that depends on the URL encoded version of our header, the URL encoded version of our payload, and a secret key that I set down here. So this signature will only be accepted if the sender signed it with our secret key and it contains this exact data. If in transit someone tries to change this data, they will not be able to generate a new signature that matches that data because they don't have our signing key down here. Now, if you watch as I change this data, you will see that this changes. You see here BWJ. If I add another character there, you'll see now 4SS. The signature changes as the payload data changes. And that's what makes JWTs so secure. Your .NET application is going to check that the payload and your secret key match this signature. Now you can see down here, there's this signature verified. If I was to change something about this, say manipulate this, now it will be rejected. So .NET would reject this when we add JWT implementation. Same if I change this, this is no longer valid. Our signature stayed the same, but our data changed. And if either one of them changes, it invalidates the token, and that is what makes them secure. So hopefully now you understand a little bit better what a JWT actually is, what makes it special, what the different parts of the data are, and why this method of signing them makes them so secure and immune to tampering.
In this lab, we'll learn to create and decode JWTs in an ASP.NET Core application. In step 1, we're simply setting up the application. So we're going to create a new console app called JWT demo. We'll add the .NET package system.identityModel.tokens.jwt so we can use the JWT token libraries. In step 2, we're going to set up the JWT creators. This is where we actually create the token. And so we have a method called createJWT in the creator class. First thing we want to do is define our secret key. This could be anything that's relevant for creating the JWT. It has to be of a certain length, so that's why this is so long. But we'll call it our secret key as we're building the application. Then in the method, first thing we're going to do is decode the key. We're going to create a symmetric secure key by encoding the secret key that we created so that it's undecipherable. We're going to create a variable called credentials, and this is going to use the identity model library signing credentials. We're going to pass in the key and then use HS256 encryption so that the key is hidden during transmission. It's not decodable. Then we're going to create a new claims variable. So in the claims, we're going to create that JWT claim. And the first item is to register the claim name. And we want to use the .sub there, which stands for subject when we're putting together the token. And then we also want to make the JWT registered claim names.jti, and that stands for the JWT token ID. So that's where we're actually giving this very specific claim so that when the token is created, the identity of the token and the user gets permissions to whatever we're trying to give permissions to. Then we're going to create our token itself. So we're going to have an issuer and an audience. There's the claim there. We're going to use our claims object for the claim. We're going to actually give it an expiration. So the token doesn't last very long and can't be used beyond a very limited time. That's just a security measure. So we're going to add 5 minutes from the current time just to make sure that token expires quickly. And then we create a token handler and then return that handler with the token to the calling code. In step 3, we're going to look at how we decode a JWT token. So it's similar to encoding. We're just doing it in reverse here. So you can see we have a decode JWT, and then we're passing in the token that we created from the other method. And here we want to create a new handler, and this is going to be a JWT security token handler. Again, we're using that identity models.token library. And we're going to create that new JWT security token handler object and put it into the handler variable. Then we have all of our parameters, but you can see we still have the same issuer, the same audience. We're using our secret key. So the secret key that we use to decode is the same secret key that we use to encode. And only the passing code that creates the key and the one that decodes it should have access to that key. It be stored securely so that it can't be decoded in transit. Then we fill the variable JWT token with the read token using the read token method passing in the token. So the token will be unpacked into that JWT token variable. And then we're going to validate the claims by unpacking all the claims in the token that we've just decoded to a dictionary so that we can actually read the claim, the key, and the value from that token. So when the token's passed to the receiving application, it can unpack the token, read the claims, and then decide what to do with the claim now that it's been passed from the client. And that's how you encode and decode a JWT token using the identity models.tokens and the identity models.tokens.jwt libraries.
A smooth and secure user experience allows users to log in once and safely navigate an entire application. This level of efficient security is possible by using JSON Web Token authentication, a powerful way to protect sensitive information while enhancing app scalability. In this video, we will describe the process of implementing JWT authentication in ASP.NET Core. Let's begin by exploring how JSON Web Tokens, or JWTs, work within an authentication flow. First, the user logs in with their credentials, which the server verifies. Once verified, the server creates a JWT token that acts like a pass for accessing certain resources and sends it back to the user. Every time the user makes a request, they include this token as proof of their identity through an API request with the token. Finally, the server checks that token with each request. If it's valid, access is granted. If not, it's denied. This way, the user only has to log in once, but can keep accessing secure areas until the token expires. Now that we understand the JWT authentication flow, let's explore the role of JWT middleware in the process. Recall that middleware is code or software that acts as a bridge between different parts of a system, helping them communicate and work together. In ASP.NET Core, JWT middleware acts as a checkpoint, validating tokens on every incoming request before granting access to secure areas of the API and routes. It ensures that only users with valid tokens can proceed, safeguarding sensitive resources while maintaining integrity of the application. To perform this validation, the middleware relies on what's called the bearer schema. Bearer schema is an authentication mechanism where the client includes a token, typically a JWT, in the authorization header of an HTTP request to validate their identity. The bearer schema's flexibility allows fine-grained access control and scalability, but proper security measures like HTTPS and token expirations are crucial to mitigate risks. Now let's explore how securing our API routes with JWT middleware creates a secure authentication setup, starting by defining API routes. API routes are the pathways that connect users to application resources, such as personal data or order details. These routes are secured using JWT middleware to ensure that only users with valid tokens can access them. This approach protects sensitive information from unauthorized access, maintaining the application's security. With this mechanism in place, the server validates the token on each request, granting or denying access based on the user's credentials and permissions. This ensures API routes remain secure, allowing only authorized users to access sensitive resources. Now that we understand how to implement JWT authentication, let's explore an example of how it secures API routes and when a user logs into an application. First, the user submits their credentials, which the server authenticates. Upon successful authentication, the server generates a JWT containing encoded user information and permissions and sends it back to the client. Then middleware functions as a gatekeeper. It processes each incoming request by validating the JWT included in the request header using the bearer schema. This validation ensures the token is authentic and has not expired. Finally, if the token is valid, the middleware forwards that request to the appropriate API route, which is then securely sent back to the user. Using this method secures API routes and ensures that they remain protected from unauthorized access. In this video, you learned about the process of implementing JWT authentication in ASP.NET Core. By implementing JWT authentication, you create a scalable and secure foundation, giving users confidence in your application's security as it grows. All right, so it is time to have some JWTs introduced along with our .NET code. So I am going to walk through the process of implementing basic auth in a .NET application using JWTs. You can see here that we have this really simple application, and there's really not a whole lot going on here. We've got authentication, we've got authorization, and then we have the root route and a secure route. So how do we add JWTs? Well, the first thing we're going to want is to come up to our authentication, and we are going to want to use a method here, add JWT bearer. And now to get access to JWT bearer, we're going to add that package. So let's say .NET add package, and this will be Microsoft .ASP.NET Core .authentication .JWT bearer. Let me make sure I spell authentication correctly. That looks correct. Let's try that. Now it looks like everything installed correctly here. And now you should see this go away. Now, as you can expect, there's probably some settings we're going to need to set here. How does our JWT know what key to use, for example? So we are going to once again set some options, and this will be a function that gets passed in options as usual. And now let's say options dot token validation parameters, and this will be a new token validation parameters. And now I'm only going to focus on one real thing here, and this is the issuer signing key. So this is the secret code that we will use to check to make sure that a token is valid. Our issuer would need to have this exact same code to sign the JWTs. Otherwise, we will reject every one of them because we don't know if they are safe and secure. And so the way we're going to create one is we're going to say new symmetric security key, and then this will take in a parameter, and we'll say encoding dot UTF-8 dot get bytes, and then this will get passed the piece of text that we want to use as our password. Now this should be at least 32 characters long, and you also don't ever want to just write it directly in code like this. You always want to say put it in your app settings and pull it through that way, or put it into user settings, or use some kind of an external piece of software to keep that in. Again, that is because you don't want any of these important secret pieces of security information accidentally committed to a repository along with your code, where someone could get a hold of your code as well as your secret key. You don't want them really in the same place out in public. But I'm going to write it here just to make it really, really clear what is going on. I don't want anything to sort of get in your way of understanding that all we are doing is using a piece of text to check that our JWT token is correct. So I'll say don't ever leave a key in like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, and just a couple more digits to make sure we're nice and long. And now there are a couple other pieces of information that I'm going to tweak here. Now you wouldn't normally want to do this, but I want to tackle these issues later. So let's say validate issuer equals false. Then let's say validate audience also equals false. And then let's say validate lifetime equals false. I want to start really simple here. And again, you would never want to do this in practice. These tend to be really good practices. You want to validate the issuer, you want to validate the audience, and you want to validate the lifetime. So you would want all three of these set to true in a normal occurrence. But this will make it a little simpler for us to generate tokens and see exactly what's happening early on. And so now we have done everything we need to make JWT-based authentication work in our application. We should be able to save this, come down here and go .NET Watch, and we should now run our application. And if we come over to our requests file, I should be able to hit our root route and get that. And then I should see that our secure route is blocked. So now I need a JWT. Now, you can issue your own JWTs. We could create .NET code that would allow a user to log in and then get a JWT. That is something that people do. But often we work with external issuers. So this might be an issuer like Microsoft. It might be an issuer or like Auth0. It might be another service that we've built that issues these JWTs. It doesn't matter where they come from. Any JWT that is signed with this key will allow them into our application. And just to prove that, I am going to just open up a browser and I'm going to use jwt.io to create a JWT just sort of out of thin air. So now I have some data in here. I will add our secret. Now I should be able to take this token, which is now a valid JWT signed with this key. It doesn't matter what is inside of this token because we're not checking for any specific roles or claims or information. We just need to have a valid signed token to show that our user has been authenticated. So now if we come over, the way we pass these tokens along with a request is we use the authorization header and we start with the words bearer followed by that token. Let me go ahead and turn in word wrap to make it a little easier to see what's happening there. Now, if I send this request, now I am getting a 200 OK, and that says this is a secure route. And remember that if I was to say change that signature, all of a sudden it is invalid. And if I was to change the payload, same thing. It is now invalid. So this is a tamper-proof token that was created using that secret key that we had. Again, these can be issued from any issuer, your own application or another. The key things are that it is signed with that key, that our application will look and see what's in the header, the payload, check our key with this signature and that data, and if the three all make sense together, then this is a valid token. And so now that this user is logged in, you could, in your route, pull any of this data off that you wanted to, and you know that you can trust it because it has been signed. If it says they have this user ID, if it says they have this email, if it says they have these roles or claims or permissions, as long as you trust that issuer, the person you gave the key to, the application that you gave the key to, that is safe data to interpret as you see fit. So really quickly to recap, all it took to set up JWT authentication in our application was to add JWT bearer to our authentication and then set this symmetric security key. And again, we will talk a little bit about these issuer, audience, and lifetime later, but we went ahead and set these to false. Normally, you do not want this, and you absolutely should always take this key and put it in something like your app development settings or in user settings. And then that allows us to take a JSON token, and again, you pass those by using the authorization header, and then you start with the word bearer followed by the exact value of the token that came in. And that is how you use these stateless JWT tokens that can come from any issuer with your secret key.
In this lab, we're going to implement JWT authentication in an ASP.NET Core application. So I have a basic P.NET MVC app here, and I'm in programs.cs file, and in step 1, we're going to set up the middleware for authentication. I'm using the identity model.tokens library and the authentication.jwt bearer library as well. So those are important to install, and then we can set up our middleware in program.cs. So the first thing we're going to do is add our authentication service. We have a builder.services.add authentication, and we're going to use the JWT bearer defaults.authentication scheme as a property that comes from the JWT bearer library. So we'll add that first. And then we're going to add information for our bearer token, and we're going to use JWT bearer as the first option, and then set a number of other options using the option keyword. For the options, we have our issuers, whether we're going to validate the issuer, whether we're going to validate the audience, or whether we're going to validate the lifetime. All of those are set to true. And then we have a valid issuer, and that can be any domain. For the example here, we're just using your domain. And then the valid audience is going to be whatever audience API we want to use here. Now, we can use an email address, we can use a username. So I'm just putting your API as a name for the API that will be the audience. Set the issuer signing key property, and that's going to be a symmetric security key. We're going to encode it with UTF-8, converting it to bytes using UTF-8 encoding. And we're just passing in here a keyword that's used both for encoding and decoding the token. So this can be anything, but it's typically a long random set of digits, and that's what we use to create that security key. So that sets up the options for our token, and then we're injecting that into the API using this middleware setting. And then in step 2, we're going to secure the endpoint. So I'm going to go into the controllers folder and look at product controller, which is where we're setting up that route. So you can see here we have a route API and then whatever controller that we're using. And then we've set up a class called product controller. In this class, we have a get method that will return any list of products that we want to supply. When the get all function runs properly, we're just going to return OK with the list of the products as a part of that method. And then we're going to also include a get method where an application can get products for just a specific ID. So this one will also return a product, but it will only return a single product based on the ID. So when we return OK, we want to return that valid status, but just provide that one product that we looked up based on the ID that was passed in. So that's how we create a token, and we use that token in our controller to secure the requests that are coming into the API. You can see we have an authorized tag here so that only authorized users that pass in a valid token can retrieve data.
Every time an application shares sensitive data, like health records or financial details, it opens a potential security vulnerability for unauthorized access. Securing these data gateways with precise controls like JSON Web Tokens ensures that only trusted individuals can pass through. In this video, we'll explain securing API endpoints using JWTs. Recall that an API endpoint is a specific URL where clients can send requests to interact with a server. Now let's explore how to secure API endpoints with JWTs. When a user attempts to log in, JWT validation is performed. JWT validation is like a checkpoint that confirms a token is trustworthy and hasn't been tampered with. Only tokens that pass this validation are allowed access. So, how is this process performed? First, the server checks the token's unique signature to ensure its authenticity. This step prevents any altered tokens from passing through. Then, the token's expiration is checked. Each token has an expiration time, like a time-limited pass. Once it expires, the user must log in again to get a new one, ensuring only current tokens can access data. Another part of securing API endpoints with JWTs is using JWT middleware to automate token validation as a security gate for every request. Once set up, the middleware in ASP.NET Core checks each token's authenticity and expiration, blocking any requests with an invalid token. This way, only authorized requests reach secure API routes, ensuring sensitive data stays protected without manual validation. Once JWTs are validated and middleware has been set up, we can add another layer of security with role-based access control, or RBAC, which sets permissions based on a user's role. Role-based access ensures that users can only access data or functions they're authorized for. Now let's explore how all these elements come together in an example for a medical company that needs secure API endpoints for authorized users only. First, we start with JWT validation. When a user logs in, the company generates a JWT specifically for them. This token carries claims or information about the user's role and permissions. Each time the user sends a request, JWT middleware automatically checks the token to ensure it is valid. If anything's off, access is denied immediately, keeping the system secure. Finally, each token carries specific claims that define a user's capabilities. For example, those assigned the role of doctor have permission to edit records, while those assigned the role of patient can only view their information. These security steps in the company's system require every request to pass validation and match the permissions in the JWT. This way, sensitive patient data is protected and only accessible to those with the right level of access. In this video, you learned about the process of securing API endpoints using JWTs. With JSON Web Token validation and role-based access, applications can provide secure access, ensuring data is available only to those with rightful permissions. JWTs aren't just about authentication. They're also really useful tools for sort of handing around credentials, so maybe roles or claims, so that we can actually use the information held in them for authorization. So they're useful for both authentication and authorization. So in this video, we are going to talk a little bit about how to extend our sort of really basic authentication setup here with JWTs to doing something a little more expansive by checking for roles for specific routes. So the first thing we're going to do here is we are going to add a couple of new routes. And now this is going to look really similar to some of the earlier work of securing routes. So this one, we will say we want them to have to be an admin. And this one, we will again create an IT department claim. And this one, so we'll say once again, admin role. And this one will be, let's call it IT claim. Let's change the text to say this needs an admin role. And then let's say this needs an IT claim. So we now have these routes that will be locked unless a user has these correct roles. So how do we add those roles? Well, we're going to change add authorization to add authorization builder once again, and then we are going to add some policies. So the first policy we will add is .add policy, and we will call this one admin, and this will take in some options, and then we'll do options .require role, and then that role will be admin. So that is how we require that admin role. And then let's add another policy here. And this one I will call IT department. And then again, some options there. And then we'll say options.require claim this time. And it will take in two values, the key for that claim and then the value. And so we will say this is the department key. And then the value will be IT because these claims are key value pairs. And so now we have these built up. So this should be everything we need to add to now have these roles protected by these policies. Now what will change is what we need issued in our tokens. So let's go ahead and save and then start our application. I will once again open our requests file and then make this wrap so it's a little easier to see. And then I can send a request to our root route and we can get that. And I can also send this to our secure route using this token. But let's go ahead and copy this down and try to make some calls to our IT claim route and our admin role route. So if I try to make this request, I now get a 403 forbidden and I get a 403 forbidden there. So we'll say IT claim here, and we'll say admin role here. So how do you actually add roles and claims to tokens? Well, that's something your issuer does. Remember, if we look at a JWT, the information that's carried along is held right here. And we can trust that information because it's signed. So the JWT can come along with the roles already defined. So we are going to create some values here. So we'll just say role, and then we'll give this the value admin. So now I can take this key with our role admin. So this is now in the payload, and I will come back here and I will paste that in. If I try to send that, I'm going to get a 403. Now let me see why that was. I believe that needs to be a lowercase r. Again, copy that. Let's make sure this actually goes through. And that works. So this is how you add a role to a JWT. You simply give it the role key with the value you need for that role. It just goes in the payload. Now, it is also possible that you could keep the roles statefully in your backend and you're just using the JWT to authenticate who the user is. You would then grab that user and then go ahead into your backend, check what roles they have and whether or not they're able to do something. That is another option. You can combine these different security methods. But if you want the roles to come in through the JWT, it is absolutely doable. So now that we've seen how to do our roles, let's go ahead and show how to do a claim. So remember, we needed a claim for the IT department. Well, we can just say department here, and then the value will be IT. Now I should be able to grab this token once again, And I should be able to put it in here where we need this IT claim and send that request. Let me come back here and check IT department. We need Department of IT. I made that lowercase. Save this once again. Go ahead and refresh. Now try that one more time. And now we get a 200 OK. So to show what happened there, this was capital I lowercase t rather than capital I capital T. And then our token had the value capital I capital T, and it was looking for this instead. So that has to match case sensitive. And that is all it takes to add a claim to our role. Now we have this token that has both the role and the department, so I can actually use that one token in either place. So you can see we can use it here and we can use it up here. And that is because all .NET is doing is looking to see if the role value is there or if the claim value is there in their respective policies. I could put any other information in that payload. It is looking for those specific keys and values to validate these policies. And remember, these could be issued by anyone, any issuer that has our secret key. We are trusting that those roles and claims should be there because they are signed correctly using a JWT. And with that, we have now implemented two different policies, one for a role and one for a claim, in our .NET application using JWTs.
In this lab, we're going to secure API endpoints using JWTs in an ASP.NET Core application.
So I have an ASP.NET web application set up here with program.cs showing on the screen. And what we're going to do first in step one is set up the application. We want to make sure that our application can use any controllers that we create. So we're going to add that to the builder. So we'll use builder.services.add-controllers, and this will force the app to search the code base for any controllers that we create. In step two, we're going to configure the JWT middleware. This is where we set the properties for creating our tokens. For the options for our tokens, we have several options that we can set. We're going to set validate issuer, validate audience, lifetime, and issuer signing key all to true. And essentially what we're telling the token creator to do is to make sure that the issuer, the audience, how long the token stays alive, and that there is a valid issuer signing key. We want to check all those when the token is encoded and decoded. These are the properties that we're going to set for our token creation in this service. Finally, we want to add a singleton to our builder to make sure that we can use the token service anywhere in the application. And so we set builder.services.add-singleton to token service, which is from the token library that we've installed and added at the top of our program.cs file. And then in step three, we're going to secure API endpoints. I'm going to go to this authorize controller here that we have set up, and I've got a class called authorize controller. And in that class, I've got a get method that we're going to use to authorize users that want to use the method get secure data. And you can see I have an authorize property here with a policy of admin policy. So only admins are able to call this method get secure data, which we can imagine would actually return secure data back to the calling function. And that authorize keyword allows us to use the token policy that we created to enable clients to have access to that particular method of the code. So by using JWT tokens and using a route that is secure with the authorize policy, we can use those tokens to create secure code in our web APIs.
Secure access is more than a feature. It's a core responsibility for organizations handling sensitive information. And JSON Web Tokens, or JWTs, have emerged as a popular solution for ensuring secure, stateless authentication and authorization across applications. However, their effectiveness depends on proper management and implementation. In this video, we'll identify best practices for implementing secure and maintainable JWT authentication. Let's begin with a simple but essential practice: setting expiration times for JSON Web Tokens. Token expiration is the amount of time a token remains valid. This limits how long a token can be used, reducing security risks in case it's compromised. Setting JWTs to expire quickly, for example within 15 minutes to 1 hour, limits exposure if the token is compromised. This is especially helpful for apps where security is a top priority. For example, a banking app may use short-lived tokens to keep users securely logged in. This way, if a token is intercepted, it remains valid only briefly, minimizing the potential risks. Short expiration times help protect user data if a token is intercepted. However, refresh tokens allow the application to issue new access tokens without requiring users to log in repeatedly, balancing security and convenience. Refresh tokens are special tokens that allow clients to renew their JWT without re-authentication. They add security and convenience by issuing new JWTs without constant re-authentication. Storing refresh tokens in HTTP-only cookies protects them from being accessed by scripts, which helps prevent cross-site scripting or XSS attacks. HTTP-only cookies are a special type of browser cookie that cannot be accessed by client-side scripts, such as JavaScript, enhancing security by limiting access to the server only and keeping sensitive data safe from potentially harmful scripts. When you store refresh tokens in HTTP-only cookies, you further enhance security during the authentication process. It's also best to grant refresh tokens only the minimum permissions necessary, usually limited to issuing new access tokens. This way, the damage is limited if a refresh token is compromised. The next best practice is to secure tokens so only trusted parties can create and verify them. To protect JWTs, secure signing algorithms are used to make tokens tamper-proof, ensuring they can only be modified by the original issuer. This protection is especially important for applications in fields like healthcare and banking, where maintaining data accuracy and integrity is critical. The second way to secure JWTs is to keep the secret key safe. This key is used to create and verify tokens, ensuring their authenticity. If an unauthorized person gains access to the signing key, they could forge tokens, bypassing security measures and compromising the entire system. To prevent this, secret keys should never be hard-coded into an application's codebase or stored in publicly accessible files. Instead, they should be stored in secure locations, such as environment variables. Environment variables are system-level settings that store configuration data for applications. They allow sensitive information like secret keys or database connection strings to be managed outside of the application code. This approach keeps credentials secure and makes it easier to update them without changing the code. A third method is encrypting our JWTs if they contain sensitive data. While signing confirms identity, encryption ensures that only intended users can read the data. For example, a healthcare app could encrypt JWTs containing patient information, ensuring only authorized users can access it. This keeps private data secure and aligns with privacy regulations, adding a layer of protection to sensitive information. Now that we have secure and convenient token practices in place, let's move on to performance considerations. These practices keep JWT authentication efficient, especially under high demand. One way to optimize for performance is by caching validated tokens. This reduces repeated checks, improves speed, and temporarily stores recent tokens validations so that the application doesn't have to recheck every time the token with the database. Another method for optimizing token performance is reducing token size. This can be done by including only essential data like user ID or role, which helps speed up processing. In this video, you learned about best practices for implementing secure and maintainable JWT authentication. By implementing these best practices, you're not just following security steps, you're building a foundation of trust that your users can rely on. We've learned how to work with JWTs and how to implement them in .NET, But up to this point, I've actually been deliberately showing some practices that aren't exactly the most secure. And the goal was to then be able to show you sort of how to implement the best practices. Some of these things are very easy to do by default to just have your app be secure. And in this case, I have sort of gone out of my way to show you a poor way to do things. Namely, you don't ever want to save your key directly in code like this, and you should always validate the lifetime of a token, and you typically want to validate the issuer and audience as well. So let's go ahead and tackle one of the first ones, and that is getting this out of code. So there are a bunch of different ways you can do this, and the reason you don't want to leave this in code is that if anyone ever got a hold of your code base, they now have your key and your code base at the same time. If you were to say, save this to version control like Git, and someone was to get a hold of your code base, they still don't have your key. So they still can't do anything especially malicious, hopefully. So at a minimum, I would take this value out and I would go ahead and add it to my app settings. And now I can call this anything I like, but I'll call this JWT key, and then I will put this value here. The only way that this makes it safer is if when I'm using version control, I do not commit this file with the rest of my repository. Now, if you're using Git, you would create something like a git ignore file and specifically say that I do not want to commit this file. And that means that anytime someone else wants to use this application, so if I gave one of my coworkers this code, I would need to also then additionally give them this information separately so that they could stand the application up. But now that we have our value here, I can go ahead and save this. And now how do we access that value? Well, let's go to our program. And this time, let's just make a new variable up here. And let's just call this var JWT key. And then let's set this equal. We will grab it off of builder.configuration. And then we will get that by its key value. That was what we set over here. That's this JWT key. And so now we have that JWT key, and I can just replace that value in here instead of our original string. And then I am going to restart my application, and it's going to give me squiggles here because this could be non-existent. It could be null. So normally you'd want to say like throw an error or set this to a default or something like that. And now that I've reset my server, I can come back here and I can test using that new key, and we can see that it indeed continues to work. We are now getting the key from our settings rather than directly from code. Now, as I mentioned, this does have the security vulnerability of you need to make sure to not include it in your committed code when you save it to a repository. So another way to store these is using a technology with .NET called user secrets. So if we come down here and we say .NET user secrets, plural, and then type -h, we can see here that we get some information about using .NET user secrets. So this is a secret manager. So this is for holding secret information outside of our code base in a place that makes it quite secure. And so you have some flags here. And now the main things are we can clear all of our secrets. We can initialize this, which is what we want to do first. We can list all the secrets, remove them, and set a specific secret. So let's first pull up one of the relevant files here, which is our CS proj file. So now you're going to see a change in this file when I do .NET user secrets and then init. So you will see that it added this user secrets ID. So this is a special ID that will be a placeholder for where our secrets will go. And now we can say .NET, let's create a new secret. So I'll say .NET user secrets and then set, and we need a name and a value. So I will say my other JWT key, and we will give this a big old JWT key value. Just making something up here that's not terribly secure, just rolling your fingers across the keyboard like that. And now I can hit enter, and that should send this through. Now, what did that actually do? So if I go down and I open my folders, so I've now opened up my folder, and you can see that this will store data in a special place. So I will go to app data, which is just a folder on my machine. Then I can go to Microsoft, and then I can go to user secrets, and you'll see this code matches that code. So if you create multiple projects, they will each have their own folder here. And if I click that, I can open this file, and we will see here that I have my other JWT key, and it has these values. Now, this is just a JSON object, and what happens is when our application starts, it will get blended with this data. So it's sort of doing the same thing as coming down here and just taking this and adding it to this. except it's not actually kept in our code. It will do that all behind the scenes. So now I access this in the same way. And so I would come down here and I would say my other JWT key, which is the key I gave to that. And then this should still connect through. Now, this time around, we gave it a different key. So let's go ahead and come back over here and restart our application. And then if we create a new JWT using that code that we created, I should be able to take this key, come over here, put it in to replace our key, and then continue to hit that secure route. So that is how you would set a secret using user secrets, which is a relatively safe way to do that. Now, this will only work in your development environment. You would want to use another system like a hosted secret storage system, which is offered by Microsoft to store those in production, which is a really great way to do this as well. You could also sort of hard code those into development settings. Again, make sure those just don't get set with the rest of your code into version control. So that's how we secure our key. Now, there's a couple other pieces of information here that we want to secure as well. So let me close a few of these. And so looking here, we now have our key secured, but I'm saying don't validate issuer, don't validate audience, and don't validate lifetime. So these are three specific values. The most important of these, I would argue, is validate lifetime. One of the key security features of tokens is making sure that if someone was to get rid of a token they shouldn't have, that you limit the amount of time that they could do something malicious with that. And so validating lifetime means that we can actually on our token set a couple of values. One of those is going to be IAT, issued at, and this is an epoch time. So this is a specific time. You can see here, it looks like this is 5:30 and 22 seconds on January 17th, 2018. And so this would mean when this was good from. And then we can say EXP, which is when it expires. And then if we use that same date here, we now have a key that really was never usable because it was valid for 1 microsecond. But if we take this value and we bump up one of these numbers, you now see we have January 17th to January 25th, for example. And so using this validate lifetime means that we will check to make sure that the current time for our system is between the issued and expired time. So I would set this to true to make sure that this is a valid token. So once again, if I save this and restart, I can come to my requests and I can click here and we will get the token has no expiration because our original token that we made has no expiration. And then if I use this token because we have, it was issued 6 years ago and then expired 6 years ago, we can also test to make sure that this does not work as well. And you can see here that it expired in the past, which is exactly what we want to see. And so finally, I will create a new epoch time. There are some online tools. Let me see if I can find something useful. There we go. So this is the current epoch time. So I will put that there and then I will copy it again. And once again, I will just knock that number up a bit to make sure that we are now in the future. And this should work, I believe. And now if we send that, we see that this is now secure. So that is what creating this lifetime does. So ideally, you're setting a token that is, only available for maybe a few minutes, maybe 30 minutes, maybe an hour, but some small amount of time. And then you can use a refresh system to make sure that users can continue to get new tokens in case one is accidentally intercepted. It allows them to continue to stay logged in without needing to worry about their tokens being stolen and then someone being able to use that token 2 years from now. Then the other pieces that you can use here are validate audience and validate issuer. Now, these are two pieces of information that aren't necessarily like hard security features. Really, the key thing here is the security key matches. Validating issuer and validating audience are sort of making sure that you don't actually goof something up behind the scenes. So issuer is a string that's meant to signify who is issuing that token. Now remember that you can only trust this because it has been signed with your key. And audience is who is this meant for. Now, why would you want to use these? Well, so imagine you have an application and you are going to actually use multiple issuers for some reason. It can be useful to be able to tell who issued that key. Maybe you're getting different information from one versus the other. Maybe one is more trustworthy than the other. So that is why you could use issuer. And then audience is who was this key meant for? Who is this meant to be consumed by? This should be your application. Now, again, you can name this anything you want. It is pretty common to save this as, say, the domain of your website that will be serving this application. And this is meant in case maybe, let's say you're building a big application that has a couple of different backends and you have an issuer and you accidentally set it to configure to send a token to one when you meant to send it to another. This will sort of flag that to make sure that you're not trying to consume a token in the wrong place. And so if you set these two to true, they will also want a value for what they should be. And so let's say valid issuer, and we'll say the valid issuer is my issuer. Again, this could be any value you want, and we'll say the valid audience. We'll just use a sort of shortened version of our domain. Let's just use the whole thing. So we'll say / localhost 5030. And so now, again, if we save this, we restart our application, you'll see that now we're looking for some new values on our token that aren't going to be there. So if I come back here to my request and I hit send, I'm now getting the audience empty is invalid. So if I go back to generate a token, I can set odd using the AUD key, lowercase a there, and we'll say that audience was http://localhost 5030. And then we will also want an issuer, which is an ISS claim. And this one will be, I believe I call that my issuer. Let me check. That is my issuer with a capital M. So now I can grab this token again, pull it over here, and we should now see that this is, again, a secure token. And so these are just a few examples of how you can use JWTs to make them more secure. Another handy feature that you might want to use here is .NET's user JWTs tooling. So user JWTs allows you to sort of, in the same place you would create secrets, actually create JWTs for testing. And so you could say .NET user JWTs, and then let's say create, and then we will need to give this a couple of flags. So let's do -h to see. It looks like I goofed that up. So let's do .NET user JWTs. I spelled .NET wrong the first time, and then create -h. And now we will see here some of the flags I can set. So what is the scheme, audience, issuer, scope, role, claim, not before, expires on, and valid for. Now, I don't want to go through the trouble of figuring out the epoch times, but just for example, we could say .NET user JWTs create, and then let's say audience is test audience. This won't actually match our audience, but this just kind of shows you how you do this. Then issuer will be my issuer. And then this will give us a new token here. It sort of has this ID, but ultimately this is the token we care about. And I can say .NET user JWTs list, and I can see that I have a list of my JWTs. You can also figure out what your key is. You can say .NET user JWTs, I believe it's key. And this will tell you what your secret ID is here for creating tokens. And so then you would need to, if you want to use these keys, wire them up to have the correct information here, the correct issuer, audience, and the key here. Now, one thing to note is when you pull this key in, it will be base 64 encoded if you generate it from .NET user JWTs, which means that instead of calling the encoding.utf.get bytes, you would want to use convert from base 64 string. And then you would pass in the builder.config value that was set for that. And now, in case you're wondering what those are, if we go back to our Finder, you can see here that it did a couple of things here. One, it created a JWT here in this list of user JWTs. Let me see if I can get this to auto format. And so this is the token. This is some of the information around the token. Ultimately, this is what matters, but this sort of gives us some information that we could use to tell what was encoded in this. Additionally, if we go over to our user secrets, you'll see this is where our key is stored. And it is in this authentication schemes bearer signing keys. Notice this is a list and then the value. So if we wanted to get this from our builder configuration, we would do something along the lines of builder.configuration, pass that in, and then it is the first value in the signing keys, and then I believe it is the value of that. And then this should give you the information to pull that key in, And again, you would want to change the issuer and the audience to match that. It will also have made a few settings in here. It added these as well. It added our audience schemes, bearer, then the valid audience and issuer. So you would want to use this audience and this issuer. So that is how you set up secure JWTs for your development server, and as well as the ability to generate JWTs locally so you don't have to use a tool like jwt.io. JWTs are an incredibly powerful tool. Again, I highly recommend using cookies when you can. They are an incredibly good option in the right environment, and when you cannot, absolutely use JWTs. They're an excellent security tool. Just know that there are some little issues you need to work around and that you need to make sure to implement the best security practices to make sure that they are as secure as possible.
In this lab, we're going to apply security best practices for JWT authentication in an ASP.NET Core application. In step 1, we're setting up the application. I have a basic ASP.NET web app here, and I'm in the program.cs file. And the first thing we want to do is use the add controllers method on the builder.services object to make sure that we can include any controllers that we create in our application. In step 2, we're going to configure the JWT authentication. So again, we're going to use the builder.services object here and use the add authentication method on that object. We're going to pass in bearer to indicate what type of token we want. And then we're going to add options for our token. And you can see we're using the token validation parameters object to create the options for our token. For validate issuer, validate audience, validate lifetime, and validate issuer signing key, we want all those to be true. I see I have an error here, so I'm going to fix this one. Make that true. We want all these to be true. So that's just going to allow us to make sure that our token does all the validation that we need when we're creating it. Those options will be set. We'll pass those in when we create the parameters. And then we're going to set the clock skew. And this is just how long we want our token to be alive. The clock skew allows for differences between the server time and the client time. Here we're setting it to 0. So when the expiration happens, those clocks have to match exactly. The default is 5 minutes. Here we're just setting it to 0, which can mean tighter security, but can also cause some problems if the clocks are off. And then finally, we're adding a singleton here also on the builder services object. And we're adding a singleton for the token service. The token service is a service that I created in this app that just allows us to manage tokens a little bit more easily. We can use that token service throughout the app by adding this singleton in the builder.services object. Step 3, we're going to create the protected endpoints. And for that, I'm going to go to my authorize controller here. And this is the controller that we'll use to call the secure endpoints. And you can see we have a method here, get secure data. And we have a policy and a role property on this method. So here's where we set the policy. The method can only be called by those who are admins, and the role has to be admin as well. So the policy restricts what types of users can access the method, and the roles are those particular roles within that restricted policy. So by using the policy and the roles, we can make sure that only authorized users are able to call this method. And here, obviously, we're only returning OK with the message success and the role defined as admin. But we can do anything we want, obviously, in this method. Get secure data would probably return a package of confidential data. And so you only want admins accessing that data. Those authorized properties give us those restrictions.
Effective access control and authentication are essential for securing modern applications and ensuring that only authorized users can access sensitive resources. In this module, we began by exploring the fundamentals of role-based access control, RBAC, highlighting its importance in managing user permissions and enforcing security policies. Next, you learned about JSON Web Tokens, or JWTs, gaining an understanding of their structure and how they facilitate secure, stateless communications. Then, we examined how to implement JWT authentication in ASP.NET Core, focusing on practical steps to integrate JWTs into your applications. After that, we explored securing API endpoints with JWTs, ensuring your application resources are protected against unauthorized access. Lastly, you reviewed best practices for implementing JWT authentication, equipping you with strategies to create secure and efficient systems. Congratulations on completing role-based access control and JWT authentication. You've taken a crucial step toward building more secure and reliable applications. Welcome to Data Protection. In this module, you'll learn essential techniques to safeguard sensitive information, whether stored or in transit. From encryption to secure data storage and masking, these concepts are critical for protecting user data and maintaining compliance with security standards. By the end, you'll be equipped to implement robust data protection strategies in your applications. We will begin by exploring the principles of data protection and understanding why safeguarding sensitive information is essential in today's digital landscape. Next, we'll examine encryption and decryption, uncovering how these processes transform data into secure formats and ensure confidentiality. Then we'll dive into data masking and obfuscation, learning how to conceal sensitive information to minimize exposure risks. After that, we'll focus on best practices for securing data storage, ensuring your applications protect information at rest effectively. Finally, we'll explore methods for protecting data in transit, enabling secure communication and safeguarding data as it moves between systems. Mastering data protection techniques is fundamental for building trusted applications and ensuring the security of sensitive information. Let's get started with data protection. Every second, sensitive information moves through digital space. Protecting it requires constant vigilance to keep it private, accurate, and accessible. In this video, we will describe the core principles of data protection, including confidentiality, integrity, and availability. In data protection, confidentiality, integrity, and availability are the foundational principles that ensure information remains safe and accessible when needed. Let's get started by defining confidentiality. Confidentiality is the principle of limiting access to sensitive information, ensuring that only authorized individuals or systems can view it. It protects privacy and prevents unauthorized access, disclosure, or use of sensitive data. Think of confidentiality like the lock screen on your phone. Only you can unlock it to access your messages, apps, and files. In data protection, confidentiality does the same thing. It keeps information safe by allowing only the right people to access that sensitive data. For example, a company might keep customer data private by allowing only certain employees to access it, keeping information safe and secure. Now that we have explored confidentiality, let's move on to integrity. Integrity is the principle of ensuring that data remains accurate, consistent, and unaltered throughout its life cycle. It involves protecting information from unauthorized changes, whether accidental or intentional, and implementing measures to protect and correct any tampering or corruption. In data protection, integrity is like sending text messages. When you send a message, you expect it to arrive exactly as you wrote it. In data protection, integrity ensures that information stays the same as it's transferred or accessed. No unwanted changes, no tampering. For example, a business ensures integrity by regularly checking its records to make sure customers' orders and inventory stay current. While integrity keeps data accurate, availability makes sure it's ready and accessible whenever someone needs it. Availability is the principle of ensuring that systems, data, and resources are accessible to authorized users whenever they need. It minimizes downtime and disruptions, maintains productivity, and enables timely access to critical information. In data protection, availability is like having a library that never closes. It's open all the time. You can count on it being accessible whenever you need a book or some information. Availability means that systems and data stay up and running so users can access the information when they need it anytime. Now that we've covered each principle of data protection, let's explore how a company could integrate them to protect its data. Imagine a company that applies the 3 principles of data protection to safeguard customer data effectively. First, they use confidentiality by restricting access to sensitive customer information, like payment details and personal data, using encryption, secure authentication, and role-based access control to prevent unauthorized access. They also manage the integrity of their data by ensuring accuracy and consistency of critical information, like orders and inventory data, by implementing checks, validations, and backups to detect and correct any unauthorized changes or errors. Last, they enable the availability of data by maintaining access to their services at any time. They do this by hosting their website on reliable infrastructure, using redundancy, regular maintenance, and robust disaster recovery plans to prevent downtime and ensure customers can always access their services. By combining these 3 principles in their data protection plan, the company creates a safe and reliable user experience. In this video, you learned about the core principles of data protection, including confidentiality, integrity, and availability. Together, they form a strong foundation for data protection, keeping information safe, accurate, and accessible in a connected world. Every piece of data holds value, and protecting it means keeping it private, accurate, and ready whenever it's needed. However, threats to data security are constantly evolving, making it essential to understand what we're protecting against and how these threats impact data. In this video, we'll identify common threats to data protection and how they impact confidentiality, integrity, and availability. Each core principle of data protection can be understood by examining the different types of threats it protects against. Let's begin by examining a few of the most common threats to data protection. First, unauthorized access occurs when someone gains access to data without permission. This threat impacts confidentiality because private information is exposed to those who shouldn't be able to access it. For example, if a hacker gets into patient records, sensitive medical details could become public knowledge, breaking confidentiality and potentially harming individuals. Data corruption is also a significant threat to data protection. This happens when information is tampered with, either accidentally or intentionally, and poses a serious risk to data integrity, as the information becomes inaccurate and unreliable. For example, imagine a cybercriminal altering financial records in a company's system. This could generate incorrect reports, misleading decision makers, and potentially damage the company's credibility, financial stability, and overall operations. Now let's explore a threat that disrupts access to data entirely: denial of service, or DOS attacks. A denial of service attack is a cyber attack that attempts to overwhelm a service with an excessive number of fake requests, making it unable to respond to legitimate users. Imagine receiving so many spam calls from a single number that your phone line is jammed and the people you want to call you can't get through. This is similar to how a DOS attack works, where one source floods a service with excessive requests, making it unavailable to legitimate users. One type of DOS attack is a particularly hard to deal with, and it's a distributed denial of service, or DDoS attack. A DDoS attack is a cyber attack where multiple systems coordinate to flood a target with excessive requests, overwhelming its capacity to respond to legitimate users. These attacks are particularly challenging to block because the traffic originates from numerous sources, making them a severe and persistent cybersecurity threat. For example, imagine a popular online store announcing a major sale. Suddenly, instead of real customers visiting the website, thousands of infected devices worldwide controlled by attackers start flooding the site with fake requests. These requests overload the store's servers, crashing the website. Real customers can't access the site, resulting in lost sales and frustration. This is a typical DDoS attack, where attackers use a large network of compromised devices to disrupt a service by overwhelming it with traffic from multiple sources. In this video, you learned about common threats to data protection and how they impact confidentiality, integrity, and availability. Protecting data is about more than prevention. It's about understanding how each threat impacts our ability to trust and rely on our data. Sensitive information like passwords, credit card numbers, and personal messages travel across the internet every day. Without protection, this data would be vulnerable to anyone who tries to intercept it. Encryption makes digital security possible by transforming data into a form that only authorized users can read. In this video, we'll explain the process of encryption and its role in data protection. To understand how encryption works, let's start by defining it and exploring how it secures information. Encryption is the process of converting readable text, known as plain text, into unreadable text, called ciphertext, to protect sensitive data. Encryption works like a lock and key system. First, it scrambles plain text or readable data into unreadable ciphertext using mathematical rules called algorithms. Then a key acts as a special code that unlocks the encrypted data, turning it back into readable text. The encrypted data remains secure without the correct key, ensuring that only authorized users can access the information. Now that we understand what encryption is, let's examine some of the key concepts of encryption. First, let's explore symmetric encryption. Symmetric encryption is a method of encryption where the same key is used for both encrypting and decrypting the data. This type of encryption is fast and works well for securing large amounts of data when the same key can be safely shared by both parties. For example, symmetric encryption can be used to keep the data secure in a company with a shared drive for confidential files. This method encrypts the files using a single shared key or password, which all authorized users must have to decrypt and access the files. Since the same key is used for both encryption and decryption, symmetric encryption is a fast and efficient way to secure information, particularly in trusted environments where key distribution can be safely managed. Now let's explore asymmetric encryption. Asymmetric encryption is a method of encryption that uses two keys, one for encryption and another for decryption. The public key is shared openly for encrypting data, while the private key kept secure by the recipient is used for decryption. This ensures secure data sharing, as only the intended recipients can decrypt the information. This type is common for securely sharing data over the internet. Think of sending a secure email. The recipient shares their public key with you, which you use to encrypt the message. Only they can decrypt and read it using their private key. This two-key system in asymmetric encryption ensures sensitive information remains secure, even when shared over the internet. Now that we've covered the two main types of encryption, let's explore some specific algorithms, starting with the Advanced Encryption Standard, or AES. AES is a fast, secure, and widely used symmetric encryption algorithm. Due to its efficiency and ability to defend against strong security attacks, it is ideal for protecting stored data such as files, databases, and account details. Many online banking systems rely on AES to protect sensitive information like account details and transactions. Therefore, when you log in or make a transaction, AES encryption ensures your data remains unreadable to outsiders, keeping your personal information safe. Another encryption algorithm is RSA. RSA is a popular asymmetric encryption algorithm for securing data shared online, such as login credentials and other sensitive information. It is commonly used in SSL and TLS certificates, which encrypt communications between websites and users, protecting data during online exchanges. Websites with HTTPS in the URL use encryption to protect your sensitive information, like passwords and personal details, as it travels between your device and the website. RSA, or a similar asymmetric encryption method, is typically used at the start of the connection to securely exchange a secret key. This secret key is then used by AES, a faster symmetric encryption method, to encrypt the data being transmitted. By combining RSA for secure key exchange and AES for efficient data encryption, websites ensure your information remains private and safe from unauthorized access during online exchanges. In this video, you learned about the process of encryption and its role in data protection. Encryption is essential for digital security, ensuring that sensitive data remains protected from unauthorized access. Encryption and decryption are one of the most important factors for keeping data secure when it is at rest. Now, you can often do this directly in your database, but you can also do it through code. So today I'm going to explain how to implement basic encryption and decryption techniques in an application. So you're starting out with the scaffold of an application here. The goal of this application will be to encrypt and decrypt data. And as you can see here, we expect an encryption service that we are going to build. And then we will use that encryption service to both encrypt up here and decrypt our data. Currently, these are not implemented. If I hit these endpoints, they just send back a message that says this is not implemented. We also have a couple of record types here for our requests. We have an encryption request and a decryption request that just take in strings. And then we have an interface for what our encryption service will look like. It will have an encrypt method and a decrypt method. Both will take in a string and return a string. And then finally coming down, we have our service sort of scaffolded out here. Now, the method of encryption we're going to use will need a key and an IV. This is an initialization vector. You can sort of think of this as a secondary key for our purposes. We are saving these in config, and we will pull these values out right here. And this is what our key currently looks like, as well as our IV. Coming back to our code, we have our encrypt method and our decrypt method, and these are just currently returning strings. And this is what we're actually going to implement. So the first thing I'm going to want to do here to encrypt this data is create a new AES generator. So I'll say var AES, let's say equals AES. And then we don't want this ARM1, we want the cryptography. So system.security.cryptography, and that will add our using statement. And so we will create a new AES. Then we're also going to need that key and IV. So let's set those on our AES. We'll say AES.key equals underscore key. And then let's say AES.IV equals underscore IV. And so now those values are set on our AES. Next, we will create an encryptor. So let's say using var encryptor equals AES dot create encryptor. And that will take in that key, and it will also take in that IV. So now that we have the encryptor, we need a memory stream. So let's say using var ms equals new memory stream. And next, we will create a crypto stream that will consume that memory stream, our encryptor, as well as a crypto stream mode, which in this case will be writing because we are writing an encrypted value rather than reading and decrypting. So let's say using var cs equals new crypto stream, and that will take in that ms, it will take in our encryptor, and it will also take in a crypto stream mode, and we want this to be .write. And now I'm not going to put a semicolon here because I want to continue using that CS. So let's say using var writer equals new stream writer. So we need to write this, and we will pass that crypto stream. And then finally, we will take writer.write, and we will write that value, which will be our plain text here. And that is the value that is being passed in to encrypt. And then we'll clean things up by doing write.flush. Then finally, we will say return, and then let's go ahead and convert this value we're creating to a base 64 string. And then we will pass in that ms dot, and we will turn that to an array. Then we'll remove this old return statement. So again, to repeat what we're doing here, we do this AES.create, we set the key and IV, we create an encryptor that gets passed the AES key and the IV. We then create a memory stream. We pass those three previous pieces of information, or the two previous pieces of information, and the crypto stream mode to write to this crypto stream. We then write that crypto stream to a new stream writer, and then we finally write that text out, and then we convert it to a base 64 string. So I will go ahead and save this and restart our server. And in theory, we should now get back an encrypted value because that is being used up here in encrypt. You see this encryption.encrypt. That is the method we just implemented. If I come here and I try to encrypt this, and that returns this encrypted value over here. So now I can take that and put it down here so we can use it to test our decryption. Remember, again, this is not implemented. Now, decryption is going to be really similar sort of in the way we handle it. So I'm just going to start by copying this information down and replacing this. Now note that we called this ciphertext rather than plain text, but otherwise this method is really similar. So the first thing we're going to want to do is come up to the top here, and then we're going to say var buffer equals convert dot from base 64 string, and then we will pass in the ciphertext. And that should be buffer, not bugger. And so now we have that buffer holding our ciphertext. We will use the same method of creating the encryptor, but this time the memory stream, we will pass in that buffer. Then we will come down to our stream writer, and this time rather than write, we will do a read. This time I can go ahead and add the semicolon to terminate that, and then let's finally say using var reader equals new stream reader this time, and we will pass in CS. I can go ahead and get rid of this. I've got a couple of extra parens there. So now this is really similar, except we are creating this buffer. We're passing that to our memory stream. We're using the crypto stream read mode instead. And then instead of what we were doing here, where we're using a stream writer, we are instead reading from that stream reader. And then finally, I will return, instead of this, I will return reader.read to end. And I believe that is everything I need here. Let's go ahead and save that. It looks like our application restarted. Let's trust it. And that clearly does not look correct. So let's go back and see what we've done here. All right, then looking back at the code, I see what it is. I need a decryptor, not an encryptor. So to reiterate those changes, we needed to pass that buffer to our memory stream. We need to change this to create decryptor. Then we needed to change this stream mode to read, as well as use the stream reader instead of a stream writer. So let's go ahead and try this one more time. And it looks like that now works. Excellent. So I can encrypt data and then I can decrypt that data. So this is the same value as that. And so with that, we have now created what could be its own little service to encrypt and decrypt data. We will show how to use this in the future and how we can use this to encrypt and decrypt data into a database.
In this lab, we'll implement basic encryption and decryption techniques in an ASP.NET Core application. In step 1, we're setting up the application. In my web app here, it's an ASP.NET web app. I have program.cs open. The first thing we want to do is add our controller. So this allows us to make sure that the app will look for any controllers that we add throughout the application. So that command will call that method on builder.services. So it will include any controllers we need. In step 2, we're going to configure the encryption settings. We do this after the .NET env.env.load. And this is the library that we're going to use to create the encryption settings. So I create a new variable called encryption settings. And then I'm grabbing the key and the IV. The IV is the initialization vector, which is just a random key that allows every key generation to be unique. I'm grabbing both of those values from environment variables. So they're not actually in the code themselves, they're in a separate file, and we do that for security purposes. So we're going to grab the AES underscore key and AES underscore IV, and those are key names for the environment variables that we're using in our application. In step 3, we're creating the endpoint that we'll use to actually encrypt data. And we do that here in app.map_post. So it's a post method. In this method, we're doing a number of things. So we're going to make sure that the request has content. That's in the context.request.content length. We're testing that first. If it does, then we're going to try to read the JSON from the request and put it in the JSON string. If that fails, then we're going to return bad request. Next, we take the JSON string and we put it in a new variable called JSON string. We're going to call our encryption helper. The encryption helper will call the get encrypted settings. So we're going to actually get our key and IV from our encryption helper. Then we're going to try to encrypt the data. So here's where we call encryption helper.encrypt data. And that's a method in the encryption helper file. The encrypt data will pass in the JSON string along with the key and the IV and attempt to encrypt the data. If the data doesn't get encrypted properly, it will fill that encrypted data variable, and then we can return the results back to the calling application or website. Will return ciphertext, which is equal to the encrypted data that the method returned. So that's a very simple way that we can use encryption in an ASP.NET web application to encrypt data. The encryption helper also will have a decrypt function as well, and we can add a new route on our application to decrypted data as well.
Businesses handle vast amounts of personal data, from payment details to social security numbers. Protecting this sensitive information is crucial, and one key method businesses use is data masking. In this video, we will describe data masking and its role in protecting sensitive data. To understand how data masking protects sensitive information, let's first define what data masking is and how it works. Data masking is the process of altering specific data elements, often by replacing sensitive information with fictional data. The purpose is to protect sensitive or confidential information while preserving its usability for testing, development, or analytics purposes. Data masking allows companies to safely use realistic data in development and testing environments without exposing sensitive information. There are different ways to mask data, and each is useful in specific situations. Let's explore some of the main concepts of data masking. Static data masking involves creating a masked copy of data, typically for development and testing. It replaces sensitive information with fictitious values while retaining the same structure and characteristics. A bank might use this approach to mask customer account details in testing environments, ensuring privacy while maintaining realistic data for accurate testing. For example, a 7-digit bank account like 0123456 could be masked to appear as 8304652. Dynamic data masking hides information in real time without altering the original data, displaying different versions based on user access. For example, a customer might have partial details like Olivia D, ID, XXXX1234, while authorized employees can view the actual ID number. Next, we have personal data masking, which focuses on concealing sensitive details like emails, phone numbers, or credit card information. This technique is often used in customer service or testing. For example, in customer support, a representative might have only a partial phone number, such as XXX7890, ensuring privacy while enabling the confirmation of key details. Lastly, social security numbers are commonly masked in databases to enhance privacy protection. For instance, users without proper authorization may only have the last 4 digits, such as XXXXX6789, ensuring sensitive information remains secure while allowing limited access for verification purposes. Data masking safeguards sensitive information, supports compliance with privacy regulations, and enables secure testing without exposing real data. In this video, you learned about data masking and its role in protecting sensitive data. Data masking doesn't just protect information, it builds trust in every digital interaction by ensuring personal data remains secure. In a world where data is constantly exchanged, protecting sensitive information from unauthorized access has become crucial. Techniques like data obfuscation and masking help secure data, but each method serves a unique purpose. In this video, we'll explain data obfuscation and how it differs from data masking. To understand how data obfuscation protects sensitive information, let's first explore what it is and the techniques that make it effective. Data obfuscation is the deliberate process of making data difficult to interpret, ensuring its protection against unauthorized access. This technique is valuable because it safeguards sensitive information, even if someone without proper authorization gets access to it. Now that we understand what data obfuscation is, let's explore specific data obfuscation techniques, starting with tokenization. Tokenization is a data obfuscation method that replaces sensitive data with unique symbols or tokens, which hold no meaningful value outside of a secure system. This technique is commonly used to protect sensitive information, like credit card details, by hiding the original data. For example, credit card numbers stored in a database can be replaced with unique tokens in a payment system. Even if unauthorized users gain access to the database, they can only access the tokens, not the actual credit card information. Another data obfuscation technique is data scrambling. Data scrambling is a data obfuscation technique that involves modifying data so that its original value is no longer recognizable, but its format and structure are preserved. It is commonly used to enhance security, especially during transmission or storage, by preventing unauthorized access to sensitive information. For example, a company might send scrambled customer IDs over an unsecured network. Mixing up characters makes the data useless to anyone who intercepts it, keeping customer information secure. Authorized systems can unscramble the data using specific tools or algorithms like AES, restoring it to its original form for legitimate purposes, such as customer verification. The final data obfuscation technique we will explore is code obfuscation. Code obfuscation is a data obfuscation technique that makes software code to make it difficult to understand while preserving its original functionality. This method is widely used to protect software from unauthorized access and reverse engineering by intentionally making the code challenging to interpret. Developers often rename variables, inserting misleading or redundant lines of code, and restructure logic to obscure how the software operates. As a result, even if someone gains access to the code, they will find it extremely difficult to decipher or exploit it, adding an extra layer of security to the software. Now that we understand the key data obfuscation techniques, let's examine how data obfuscation differs from data masking. Data masking safeguards sensitive information by substituting it with realistic yet fictional data, making it particularly useful for scenarios like testing or training, where the original data is not required. In contrast, data obfuscation transforms data into an unreadable format, ensuring its protection in non-secure environments or during storage in development systems. This method is ideal when the goal is to prevent unauthorized users from interpreting the data altogether. In this video, you learned about data obfuscation and how it differs from data masking. Data protection isn't just about locking data away. It involves transforming it so it's useless to unauthorized users while accessible to those who need it. Data breaches can happen in seconds, but their impact can last much longer. Securing data storage isn't just about compliance, it's about protecting trust and privacy at every level. In this video, we'll explain 3 best practices for securely storing data: encryption, access controls, and data redundancy. Let's start by exploring encryption. Recall that encryption is a method of converting readable text known as plain text into unreadable text called ciphertext to protect sensitive data. Encryption is one of the most effective ways to protect data at rest from unauthorized access. Data at rest refers to data stored in a physical or digital medium that is not actively moving through networks or being processed. Because this data remains static, it can be particularly vulnerable to unauthorized access if proper security measures are not in place. Encryption is a fundamental method for securing data at rest. For instance, when a company stores customer information, robust encryption, like the symmetric encryption algorithm AES-256, ensures that even if unauthorized individuals gain access, they only encounter indecipherable scrambled code. Without the correct key to decrypt it, the data remains inaccessible, providing a critical layer of protection. Now that we've covered encryption as a way to protect stored data, let's explore access controls, another essential way to keep data safe. Access controls are mechanisms that define who can access or modify stored information, granting permissions based on a user-specific role and responsibilities. They are often set based on roles, like an employee's position in a company. For example, a customer support agent may only need basic customer information, while a manager or a system administrator will need access to more details. Role-based access control limits each person's access based on their role, so sensitive information is only accessible to those who truly need it. Next, let's explore data redundancy, which keeps data available even if one copy is lost or damaged. Data redundancy involves creating backup copies of data to ensure its availability in case of a failure in a storage location. This practice safeguards against data loss caused by unexpected issues like technical malfunctions or equipment failures, ensuring that critical information remains accessible when needed. For example, imagine a small business keeps its daily transactions recorded in 2 places, a local backup and a cloud backup. If anything happens to the local data, the cloud backup still allows them to access it. Redundancy ensures that data remains accessible, even in cases of failure or unexpected loss. In this video, you learned some best practices for securely storing data, including encryption, access controls, and data redundancy. When encryption, access controls, and data redundancy work together, stored data stays safe and accessible when it's needed most. You've learned a lot about encryption, decryption, and securing endpoints. Well, now it's time to put that all together in this messaging app. So in this video, we will describe how to implement secure data storage techniques in an application. So I have created this messaging application. So this is an application that is meant to allow users to send in messages. We store them in a database, then they can retrieve those messages. The goal will be to encrypt those messages, but right now they are just stored as plain text rather than ciphertext. We have JWT authentication set up here, and we have these three routes that allow us to get all of our messages, retrieve a single message, or post a message. And you can notice here we have this user claim that is allowing us to take a name off of the JWT and attach that to the message. So the name that is associated with the message in the database is actually coming from the JWT. Right now, this is the only route that requires authorization. We are using our previous encryption service that we built. This has two methods, encrypt and decrypt, that do those respective operations. Then our messages have an ID, they have text, and they have a user associated with them. And then our DTO just expects the text. So just to quickly demonstrate what happens here, we have our application that we can go ahead and start it. So the first thing I will do here is pull up all messages, and you can see that we have no messages. I can send a request here, and you can see that I get this hello decryption, which is the message I expect. And then I can get that first message. If I try to change this to 2, I'm going to get an error that says that message does not exist. So I can create a couple more messages here. I can get them all. And so this is just sort of basic CRUD operations. I'm able to create messages, retrieve them, get all of them. And notice here that I also needed a JWT here with the correct name header to actually populate this name value here using name identifier. And so now what I want to do is, the first thing is I want to actually encrypt these messages, which should be pretty straightforward because we have that service we created earlier. So let's go ahead and change it so that when I write a message, we want to encrypt that when it goes into the database. Now, you could do this at the database level. Many databases support this, and this sort of shows a good way of doing it in your code. And then no matter what database we choose, we have our encryption already enacted through code rather than through the database. So this is, I believe, an encryption service, and we will call that ES just to be sort of brief there. And then you can see here that we are creating a new message here. So rather than adding the text to that message, I want to actually say es.encrypt, and that should now encrypt that message. And then we add the message, we save the changes, and then looking down here, what's returned, we return the original message, which I think is appropriate. Otherwise, they will just get back the encrypted message, and it's not going to make much sense to the end user. So we went ahead and saved that. So let's go ahead and restart our application. And now we should be able to send a post request here, and you see that we got back the encrypted message. So let me make sure what went on there. So I don't want the message dot text. I want the DTO that's coming in up here. So let's save that and let me try that. And now there we go. Now it is coming back and I see the original text. But to prove this is being encrypted, I can go to all of our messages, and you can see here that these messages are indeed encrypted. They are just showing us as not encrypted when they come back to the user so that they can see the message they wrote. And now you can see here that if I get a single message, now I'm getting back the encrypted message. Now, for the end user, they should actually get back the decrypted message. So let's go ahead and change this messages/ID to return the decrypted message. So similarly to before, we will want to pull in this service. So let's go ahead and add that here. So now we have that service. Now, if we look at our code to see what's going on, we have messages, we have the DB context.messages, we find the message. If it's not there, we say not found. So we actually just want to change this when we return it. So we'll say messages.text. Instead of that, we will say es.decrypt, and then we will just return the decrypted text. So again, let's go ahead and restart the application. And now we should be able to see that if we create that message again, I can now get our decrypted text. But again, if we check our messages, you will see that it is encrypted in the database. So this means that our data is encrypted when it is at rest, but we decrypt it to transport it. And so the message is not encrypted en route. And now you could change the application so you're actually sending it encrypted when you send it over the network. That is absolutely something reasonable. Maybe you want to decrypt it on the user side using asymmetric keys or something like that. But for these purposes, I think this is pretty good. We decrypt it when it goes into the database, then we get it out and we need to send it back to the user. We send them their original message. They did, after all, send it in the first place. And now I like having this messages route so that all the messages can be retrieved. But right now, I don't love the permissions we have set up. Right now, the post route is the only one that requires authorization. And I would prefer to change it so that maybe this messages is an admin route. So only users with admin privileges can get all messages. So let's go ahead and go to our add authorization, and let's change that to an authorization builder. Then do add policy, and we'll call this policy admin. And then that will take an options, and then we'll say options.require role. Then we'll require admin. And then I can come down here and I can say require authorization, and I want to have that be admin. So now only an admin should be able to access this particular route. And then the last thing I want to do here is modify our messages, because right now, when we get a message, any user can get a message. So the first thing I could do is I could say require authorization, and now you at least have to be authenticated. But maybe I don't want every user to be able to get every message. I think it would actually be better if users could only get their own message. So I'm going to change this up a little bit. Let's go ahead and get the HTTP context in here. And then what I'm going to do is before we send a user back a message, I first want to make sure that the user that is on the JWT that's coming in matches the user that's on that message. So I will go ahead and get my user here, and I will also get that user error right there so that if that user is not in the JWT, they will get bounced with this email required. And I actually believe it's user, not email. That'll be a little more semantically correct. And so now when we're getting a message, we are getting the user off of the JWT. We are checking if it exists. If it does not, we are returning a message to say that it is required. And so I will then check to see if the user does not equal message dot user, then I know they should not be able to access this. So I will say results dot forbid, and then that should lock them out of getting someone else's messages. So you can see here we have this context user claims default or first or default, and then we're checking for that name identifier. We check the user, we then get the message, and then we're checking to see if the user equals the user that created that message. And we know that's how it works because it's what we were doing down here. And then again, we return that decrypted message. So let's go ahead and save that, and let's take this for a test drive. So now I can come over to my requests. I can first off try to send this message, and we're going to get unauthorized, which is perfect because we need that admin role. So I'm going to create a new JWT. Let me actually test this real quick with the old JWT. Send, and I get a 403 forbidden. Perfect. So that is a valid JWT. It's signed with the right key. It just doesn't have the right permissions. So let's create a new user JWT. And let's say create, and then that's going to have a role of admin. And now I should be able to grab this, place it in for that, and then send, and now we get a 200 OK. So now I can get those messages, and we can come back here, and you can see I now have this encrypted message made by user Tyler Morgan. And now if I want to get a single message, again, I get a 401 unauthorized. And then if I come down here and I add in my token, this token will have the same user, so it should be able to access it. And now you can see I can access that message. And let's just double check this one more time to make sure that that is correct. I will change the name on this token to be something like not Tyler. Very original. Yeah, we'll go with that. And so it has this new name. Now if I come here and replace that, we should now see that we get a forbidden. And we do indeed get a 403 forbidden. So now we have implemented the ability for only an admin to access their messages, for any authenticated user to be able to create a message, but then they can only retrieve messages that have the same username. So now this would be incumbent upon us to make sure that our issuer was issuing the correct JWTs so that the users were indeed associated with the correct user when they send us a JWT. But this is a really great example of how you can lock down an application to make sure that it is secure with your data at rest. The data is encrypted, so if anyone got a hold of the database, they wouldn't be able to unlock it. If they were trying to get it at it through the API, we are making sure that only users with the correct permissions are able to access that data. Now, I'm sure there are a lot of additional steps we could take to make sure that our data is secure, but this is a really nice start to making sure that we have a secure production-ready application.
In this lab, we're going to implement secure data storage techniques, including encryption, role-based access controls, and we'll test secure storage functionality. In step one, we're going to set up the application, and here we're simply going to add the builder.services.addControllers method to our app initialization to make sure that the application can find any controllers that we add. We're doing that in the program.cs file, which is the file that runs when the application loads. In step two, we're creating an encryption service. So I have a services folder and then an encryption services.cs file. In this CS file, we're going to have an encrypt method and a decrypt method, but we have to set up our encryption services first. So at the very top, we're going to create two byte variables. The byte variables hold an array of individual bytes, and the first one is going to be underscore key, and the second one is going to be underscore IV. The key is going to hold the encryption key, and the IV is the initialization vector or initialization variable, which is just a random set of variables that will help us keep the key unique when we create that encryption key. And then we have the encryption service initializer. So here we're passing in a key and IV when we instantiate the object, and we're setting the local variables, the local underscore key and IV, to the key and IV that we pass in. So this will allow us to pass in those two variables and set them to the object's variables so we can use them in the rest of the object. So when the object's instantiated, we'll see this later, we're going to pass in those two key and IV. When we call our methods, so in the encrypt method, we first instantiate a cryptography object, the AES.create, creates that object that we can use to generate our encrypted data. And we're going to set the object's key and IV to our encryption service object's key and IV. So we're going to set AES.key to this._key and AES.IV to this_IV. So when we instantiate the encryption service, we populate those variables and then we can use them in this encrypt method. We're going to do the same in the decrypt method. We're going to instantiate the AES object using AES.create and then set the key and the IV to the encryption services key and ID that we passed in when we instantiated the object. In step three, we're going to implement and configure role-based access controls. First, we're just going to simply set up a user object. So I've got a user.cs file and under the services folder. It's a class called user, and it has two string attributes, username and role. We're going to use those to apply user-based credentialing when we access data in our encryption service. And then in step 4, we're just testing secure storage. So I'm going to go back to program.cs. In this application, this is very simple. So we're just going to do it in the file that loads when we call the application. So the first thing we're going to do is set up our encrypt settings by instantiating that encryption service. So we're going to first set a variable encryption settings by using the environment variables AES key and AES ID. These are the key and IB that we're storing in a separate file. So we're going to grab those from the file and put it in the encryption settings object. And then we're going to create byte values out of those key and IBs and set them to underscore key and underscore IB so that we can pass them into our encryption service. Then we create a new variable called encryption service, and it's just an instantiated object from the encryption service that we looked at earlier, passing in the key and IV that we pulled from the environment variables. So now that we have all of the objects created that we need, now we can actually start our test. So the first thing we're going to do is create variables for admin and user. The role for admin is going to be admin, and the role for user is going to be user. So we are essentially establishing what type of role in our role-based credentialing each user type has. So the next thing we're doing here is just creating some encrypted data out of the username. This could be anything. This could be an API call that we get back data from, and we can set that string encrypted data to the result of that API call. Here, just to keep it super simple, I'm just using user.username as data that we're going to encrypt. So first we encrypt the data, and we place it in that string encrypted data, and then we're going to try to decrypt it. We use the encrypt function in our encryption service to first encrypt it, and then in the try catch block, we're going to attempt to decrypt it using the same object, the encryption service, calling the decrypt function, and we're passing in that encrypted data that we want to decrypt. Once that data is decrypted, we place it in the decrypted data variable, and then we write out the results to the console. If we have any issues, we write out console write line access denied. And so that's a very simple example of how we can create a basic encryption service and then use that encrypted service in a ASP.NET web application.
Sensitive information moves across networks constantly, including login credentials, payment information, and messages between people. Behind the scenes, powerful security protocols work to keep this data safe from unauthorized access. In this video, we will describe the encryption protocols used to protect data in transit, including TLS and VPNs. Let's begin by exploring what we mean when we use the term data in transit. Data in transit is information actively moving from one place to another, like a message or login details sent from a customer's device to a company's server. This data is at risk of being intercepted, especially for companies handling sensitive information like customer names, addresses, and payment information. To protect data in transit from security threats, companies rely on measures that ensure information remains private and secure. Let's examine some of these measures. First, we'll explore how transport layer security keeps data safe as it travels between a customer and a company's website. Transport layer security, or TLS, ensures data is encrypted as it travels over the internet. TLS enables a secure encrypted connection between a customer's device and the company's server by encrypting the data in transit. Imagine it as sending a locked package where only the intended recipients hold the key to unlock it. During an online transaction, TLS encrypts the data and verifies the server's identity, ensuring the customer is communicating with a trusted source. This adds an extra layer of security before any personal information is shared. This process, known as the TLS handshake, ensures that data remains private and inaccessible to unauthorized users, much like a locked door to which only the customer and the server hold the key. While TLS does a great job protecting data, you may wonder why companies use TLS instead of its predecessor, Secure Sockets Layer. The Secure Sockets Layer, or SSL, was once widely adopted to secure data in transit, but due to security vulnerabilities, it has become outdated. TLS has since replaced SSL, offering stronger encryption and more reliable protection for modern applications. Upgrading to TLS is like switching to a more advanced and secure lock, an essential choice for safeguarding data. TLS protects customer transactions. However, virtual private networks are particularly useful for employees needing to secure access to company systems outside the office. A virtual private network, or VPN, creates a secure, encrypted connection between a user's device and a network, ensuring data remains private and protected over public networks. VPNs create a secure, encrypted tunnel that ensures bidirectional encryption, protecting all data traveling to and from a user's device. This allows remote employees to safely access company resources, even when connected to public Wi-Fi. When an employee logs in from outside the office, a VPN encrypts the data transmitted from their device, sending it securely to the company's network. This encryption ensures their activity remains private, even if they're on a public Wi-Fi network. VPNs offer enhanced privacy by hiding the user's IP address, making it difficult for others to track their online activities. They also increase security by encrypting internet traffic and protecting sensitive data from hackers and snoopers. Additionally, VPNs enable geo-spoofing, allowing access to restricted content by masking the user's location. Once the data reaches the company's network, it is decrypted as if the employee had accessed it directly from a secure office connection. This layered protection keeps data safe from interception, even on unsecured networks. Finally, let's examine how companies combine TLS and VPNs to create a robust, layered security approach. TLS focuses on encrypting individual connections, such as securing customer data during online transactions, and ensuring sensitive information like payment details or login credentials remain private and inaccessible to unauthorized users. It provides strong privacy by hiding the content of communication, but does not conceal the source or destination of the data. VPNs, on the other hand, create an encrypted tunnel that secures all network traffic between a user's device and a network. This approach not only protects the data's content, but also hides the source and destination IP addresses, offering an additional layer of anonymity. VPNs are particularly valuable for safeguarding remote access, enabling customers to securely connect to company networks even over public or unsecured Wi-Fi. By combining TLS for individual connections and VPNs for full network traffic, companies establish a layered defense that protects both customer transactions and internal communications. This dual approach ensures comprehensive security, addressing the distinct privacy and encryption needs of different scenarios. In this video, you learned about encryption protocols, including TLS and VPNs, used to protect data in transit. Security protocols allow companies to safeguard both customer information and internal data. These protocols form the foundation of secure digital communications, ensuring privacy and trust in a connected world. Every time data travels over a network, whether it's personal messages, financial transactions, or business files, it faces a risk of being intercepted or compromised. Understanding how to secure this data in transit is essential to maintaining privacy and trust. In this video, we will explain different methods for securing data as it is transmitted over networks. Let's begin by exploring one of the most widely used methods for protecting data as it moves across networks: transit layer security, or TLS encryption. Recall that TLS encrypts data as it travels between a client, like a user's web browser, and a server, like a website, ensuring secure communication. By encrypting the data in transit, TLS makes it unreadable to anyone attempting to intercept it, safeguarding sensitive information from unauthorized access. For example, when you enter credit card details on a shopping site, TLS encrypts this information between your device and the website server. The encryption ensures that only you and the website can access the information, protecting it from anyone who might try to intercept it. Next, let's explore VPNs, or virtual private networks. Recall that a VPN, or virtual private network, establishes a secure, encrypted connection over the internet, protecting all data transmitted between your device and a private network. VPNs act like secure, secret tunnels for your internet activity. They encrypt your data so no one can access what you're doing and can make it appear as if you're browsing from a different location. Finally, let's examine network-based protections, like firewalls and intrusion detection systems, or IDSs, which add layers of defense for an entire network. A firewall monitors and controls the data going in and out of your network, deciding what's allowed and what's blocked based on predefined security rules. Firewalls filter incoming traffic and outgoing traffic, allowing only trusted data to pass while blocking suspicious activity. This ensures your system remains secure from unauthorized access, malware, and other cyber attacks. Meanwhile, IDSs enhance security by continuously monitoring network activity and alerting system administrators if a threat is detected, similar to a security camera keeping watch. It detects and alerts IT teams to unusual or suspicious behavior that may indicate a potential threat, allowing them to respond quickly. Using firewalls and intrusion detection systems can add a crucial layer of protection to your networks by actively controlling and monitoring traffic. In this video, you learned about the different methods for securing data as it is transmitted over networks. Tools like TLS, encryption, VPNs, and firewalls form the foundational tools of modern cybersecurity. They work together to safeguard sensitive information and uphold privacy and trust in a connected world. Effective data protection is a cornerstone of secure application development. It ensures that sensitive information remains safe from unauthorized access and misuse. In this module, we began by exploring the fundamental principles of data protection, highlighting its importance in safeguarding user trust and meeting security requirements. Next, you examine the process of encryption and decryption, learning how these techniques ensure data confidentiality and integrity. Then, we focused on data masking and obfuscation, essential tools for minimizing exposure risks by concealing sensitive information. After that, you explored best practices for secure data storage, ensuring that information at rest is well protected against potential breaches. Finally, we reviewed methods for protecting data in transit, emphasizing secure communication practices to maintain the safety of information as it moves between systems. Congratulations on completing data protection. You've gained critical skills to implement robust safeguards for sensitive information, ensuring the security and reliability of your applications. Welcome to using Microsoft Copilot for implementing security features. In this module, you'll learn how to leverage the power of Microsoft Copilot to enhance security in your applications, from writing secure code to debugging and resolving issues. You'll see how AI can streamline complex security tasks. By the end, you'll apply these skills in a capstone project to solidify your understanding of security and authentication. We will begin by exploring how Microsoft Copilot can help you write secure code, reduce vulnerabilities, and ensure best practices are followed from the start. Next, we'll focus on implementing authentication and authorization using Microsoft Copilot, which will enable you to streamline these critical security processes. Then, we'll dive into how Copilot can assist in debugging and resolving security issues, giving you the tools to identify and fix vulnerabilities quickly and effectively. Finally, you'll apply everything you've learned in a capstone project using Microsoft Copilot to tackle real-world security and authentication challenges. Harnessing Microsoft Copilot's capabilities is a powerful way to build secure, efficient applications. Let's get started with using Microsoft Copilot to implement security features. Every vulnerability in your application is a potential gateway for attackers to steal data or disrupt services. Secure coding isn't just a skill, it's the foundation of building systems that users can trust. In this video, we'll describe the key principles of writing secure code to prevent common vulnerabilities like SQL injection or XSS. By ensuring all inputs are validated, you can stop many common vulnerabilities before they even start. Input validation is the process of checking user input to ensure they are safe, correct, and do not contain harmful or unexpected data. Input validation ensures only safe data is processed. For example, an email sign-up form can reject invalid inputs like random text or harmful code, preventing attackers from exploiting these gaps. Without proper validation, your application is vulnerable to attacks like SQL injection. However, SQL injection isn't the only risk. Another common vulnerability is cross-site scripting. Cross-site scripting, or XSS attacks, are a type of security vulnerability where attackers inject malicious scripts into your web pages that are subsequently loaded and executed in other users' browsers. These scripts are often embedded in comment sections, forms, or other user input fields. When unaware users interact with compromised content, the scripts execute in their browser. This can allow attackers to steal sensitive data, hijack user sessions, or perform unauthorized actions, all without the user's knowledge. Proper input validation plays a critical role in preventing XSS attacks by ensuring that user inputs are stripped of any potentially harmful code before being processed or displayed. Input validation is essential, but to build truly secure applications, developers need to follow secure coding standards. One of the most important resources for industry secure coding standards is OWASP Top 10, a widely recognized guideline for web application security. The OWASP Top 10, created by the Open Web Application Security Project, or OWASP, identifies the top 10 most critical security risks that developers should address. It provides actionable guidance on mitigating vulnerabilities like injection attacks, security misconfigurations, and insecure authentication. By implementing these recommendations, developers can create applications that are significantly more resilient to exploitation. Another method to abide by secure coding standards is to use trusted libraries like bcrypt. Bcrypt is useful for password hashing, saving you from building solutions from scratch and ensuring high levels of security. Trusted libraries help transform sensitive data like passwords into unreadable formats, protecting them even if a database is breached. Secure coding standards set a strong foundation, but regular code reviews and testing are crucial for identifying hidden vulnerabilities. Code reviews are a great way to catch issues that are accidentally missed. Imagine you're reviewing a teammate's code and notice they forgot to add input validation to a form. Detecting that early means you can fix it before it turns into a bigger problem later, saving time and avoiding potential vulnerabilities. In addition to coding reviews, automated testing tools make it easy to catch vulnerabilities in your project. They quickly scan your code and flag items like outdated dependencies or known security issues so you can address them before they cause any problems. It's a fast and efficient way to keep your application secure. Our final principle of writing secure code is penetration testing. Penetration testing puts your code through a test to assess how it holds up to real-world attacks. For example, it can uncover weaknesses in your login system, like being vulnerable to brute force attempts, so you can fix them before an attacker takes advantage. In this video, you learned about the key principles of writing secure code to prevent common vulnerabilities like SQL injection and XSS. Writing secure code ensures your systems are resilient, reliable, and capable of protecting the users who rely on them. Even a small vulnerability in your code can lead to serious security risks. Microsoft Copilot offers a powerful way to generate secure code that helps prevent these vulnerabilities right from the start. In this video, we will prompt Microsoft Copilot to generate secure code, preventing common vulnerabilities like SQL injection and XSS. Input validation is a crucial first step in securing code. It ensures that only safe characters such as letters and numbers can enter the system, preventing potentially harmful data from reaching your database or web page. Microsoft Copilot can help by suggesting code for this purpose. Let's build a basic validation function and explain each part along the way. First, we'll define a function to validate user input in C#. By prompting Copilot with, "Can you provide a C# function for validating user input that allows only letters, digits, and a specific set of characters, like @ the $, and the $sign?" We ensure our implementation meets common password requirements. Including special characters enhances password strength and security, making it suitable for secure applications. Functions like this one are typically part of a utility class to keep code modular and scalable. Start by creating a folder called helpers or utilities and define the function in a class such as validation helpers. In this case, we'll use a static function for validation, as it's efficient and doesn't require instantiating the class. Here's the code. Let's explore why this might be a good approach. Define the function by making it public. This makes the function accessible from other classes or files within the project. Then, make it static. This allows the function to belong to the class itself, not an instance, so it can be called out directly without creating an object, reducing memory usage. Next, use the bool return type. This makes the function provide a simple yes or no answer, which is perfect for input validation. Then use isValidInput to check if the function name is descriptive and clearly indicating its purpose. Next, use string input with the input parameters. This declares that the function takes a string argument as input. Finally, include string allowed special character equals with double quotes, which are the optional parameters. This allows you to specify additional special characters that should be considered valid. If no special characters are specified, it defaults to an empty string, ensuring only letters and digits are allowed. To enhance input validation, we collaborated with Copilot to design a function that supports additional special characters while maintaining security. By incorporating allowed special characters, we give developers control over which additional characters can be considered valid, making it suitable for a wide range of use cases. Let's examine it a bit more, step by step. The line, if string is null or empty, input, checks if the input string is either null or empty. If it is, the function immediately returns false. This ensures that invalid inputs like empty strings or uninitialized values are caught early, saving unnecessary processing and preventing potential issues down the line. This line converts the allowed special characters string into a hash set. A hash set is a collection that allows for quick lookups, making it an efficient choice for validating individual characters. Using this, we can easily check if a character is in the set or allowed special characters without scanning through the entire string every time. The next line is the core of the validation logic. It uses the all method to ensure that every character in the input string satisfies one of two conditions. The line char is letter or digit C checks if the character is either a letter or a digit. This ensures that the input consists of alphanumeric characters. If the character is not alphanumeric, the line valid characters.contains C checks whether it is one of the explicitly allowed special characters by looking it up in the valid characters hash set. This function ensures the input consists only of valid letters and numbers, rejecting special characters like @ the pound sign, or the $sign unless they are specified in allowed special character string. This makes it particularly useful for validating sensitive fields such as usernames or passwords, where allowing special characters without control could pose a security risk. Now that we've implemented input validation, it's time to use SQL injection, a common attack in which malicious code is embedded into a database query. To address this, we prompted Copilot with "Can you provide a C# function for secure user login using parameterized queries to prevent SQL injection?" The function should validate the username and password, allowing only letters, digits, and our special characters. Copilot suggested a solution that combines input validation with secure parameterized queries. This approach ensures user input is always treated as data, not executable SQL, and lays a strong foundation for building secure authentication functionality. To implement the solution Copilot suggested, we'll start by creating a new file called authservice.cs in the project's root folder. This file will act as a dedicated service for managing authentication logic, keeping our codebase modular and maintainable. Once the file is set up, we'll add the necessary using directive for SQL Server and define the class structure. Here's where we bring everything together to implement the secure login functionality. To start, the keyword public makes the function accessible from other parts of the program. Next, bool specifies that the function will either return true, successful login, or false, failed login. The function accepts two parameters, username and password, both of type string. In this line, we define the set of special characters that are explicitly allowed in passwords. This ensures that only these characters, exclamation point, @, pound sign, $sign, percentage sign, and up caret, ampersand, and asterisk are accepted along with letters and digits. By specifying this set, we maintain control over the complexity and format of the passwords, enhancing security while preventing unexpected or unsafe inputs. Before processing the username and password, the function uses validation helpers.isValidInput to ensure the inputs are safe. It validates that the username isn't null, empty, or contains invalid characters. Similarly, it checks the password against a stricter set of rules, allowing only letters, digits, and the explicitly defined special characters in allowed special characters for passwords. If either validation fails, the function immediately returns false, ensuring that unsafe or malformed inputs are rejected right away. This prevents invalid data from being further processed, maintaining both security and input integrity. To further enhance security and prevent SQL injection, we use placeholders in the SQL query that can check for the database's user record. These placeholders, such as @username and @password, allow us to insert user-provided values into the query safely, ensuring that inputs are treated as data rather than executable SQL commands. Add this code after the function call validation_helpers.isValidInput. Now we connect to the database using a SQL connection. The using statement establishes the connection and ensures that it is automatically closed when the operation inside the block is complete. Next, we securely add the username and password as parameters to the query. Here, we are creating a SQL command object to run our query securely. The using block makes sure the command is automatically cleaned up when we're done with it. Inside, we add the @username and @password parameters to the query. This protects us from SQL injection by ensuring the values are treated as data, not as part of the SQL code. Next, the query is executed with command.executeScalar. This retrieves a single value, in this case, the count of records that match the username and password. We cast the result to an int and store it in count. The final step checks if count is greater than 0. If it is, the function returns true, indicating a successful login. Otherwise, it returns false. With input validation and secure login in place, we'll now add tests to ensure these protections are effective. Testing helps confirm that our code block protects against harmful inputs, such as SQL injection or XSS attacks. We're building the test SQL injection function in the same file as login user to keep all authentication logic in one place. This function aims to check whether the application is vulnerable to SQL injection attacks. And here's how it works. This input simulates a SQL injection attack by trying to manipulate the SQL query to always return a valid result, bypassing authentication checks. The function passes the malicious input as the username and a dummy password to the login user method. If the application is vulnerable, this input might trick the query into thinking the user exists. If the result is true, the test fails, meaning the application is vulnerable to SQL injection. If the result is false, the test passes, confirming that the application blocks the malicious input. With input validation and secure login in place, we'll now add tests to ensure these protections are effective. Testing helps confirm that our code blocks harmful input, such as SQL injection and XSS attacks. We'll build the test XSS input function in the same file as login user, keeping all related logic in one place. This function is designed specifically to check for vulnerabilities to XSS, cross-site scripting attacks. Inside this function, we define a malicious input string that contains a harmful script, script alert XSS, with the closing script tag. This is a typical XSS attack vector that attempts to inject JavaScript into the application. If this input is not properly handled, it could execute in the browser, potentially stealing user data or compromising security. The validation helpers isValidInput method is called to check the malicious input. If the validation works as intended, it will reject the input. Based on the result of the validation, if isValid is true, the validation failed and the harmful script was accepted. The test failed. If isValid is false, the validation succeeded and the script was rejected. The test passed. With Copilot's guidance, secure coding becomes more accessible, empowering you to protect your applications against common vulnerabilities. By combining input validation, secure database queries, and simple tests, you now have essential tools to keep your code safe. Security isn't just about stopping unauthorized users. It's about ensuring the right users access the right information at the right time. Strong authentication and authorization practices protect both your application and your users, creating a safe and efficient experience. In this video, we'll describe the concepts of authentication and authorization and their role in securing applications. Let's begin with how we determine if users are who they say they are, authentication. Recall that authentication is the process of verifying a user's identity to confirm they are who they claim to be before granting access. In a messaging app, for example, users enter their usernames and passwords to log in. The system checks if their details match registered users, and if they do, the user is authenticated and gains access to the app. This step prevents unauthorized people from entering the system. Copilot can assist by suggesting best practices for secure coding, like proper handling of passwords, implementing encryption, or integrating authentication frameworks. Next, we have authorization, which is how we decide what a user can access. Authorization determines the specific resources and areas a user can access within an application once their identity has been authenticated. To illustrate, using our example of a messaging app, authorization rules allow users to view their messages but restrict them from accessing admin settings. This way, users can only reach areas relevant to them, keeping sensitive parts of the app secure. Copilot assists by offering suggestions to help developers implement secure coding practices. It doesn't directly set access limits, but its recommendations can guide you in writing stronger, more reliable code to support secure authorization processes. Finally, once a user is authorized, we have role-based access control, or RBAC. Recall that role-based access control restricts access based on the user's role. This method makes it easy to set permissions for different types of users, like admins or regular users in an app. Let's say you're setting up a company's intranet. Employees might have general access, while managers and admins have permission to use internal tools and view reports. With RBAC, permissions are clearly set for each group, ensuring everyone has the access they need, but nothing more. This setup is crucial to keeping applications secure, and Copilot can help by suggesting best practices for these role assignments. To set up roles in your app, start by identifying each role, like customers, admins, or vendors. Copilot assists by organizing these roles, making the setup process faster and more reliable. Next, map out the permissions needed for each role. Copilot suggests common permissions based on industry standards, helping reduce misconfigurations and ensuring users only access what they need. Finally, apply these permissions to your app settings, where Copilot provides reminders for best security practices to keep configurations accurate and secure. In this video, you learned about some key concepts of authentication and authorization and their role in securing applications. By combining authentication and authorization, we build layers of security that control access and protect applications. With tools like Microsoft Copilot, setting up these essential features becomes faster, more accurate, and more secure. Working with authorization and authentication code can be time-consuming and difficult, especially when you're just learning a new language. So when you're working with .NET, luckily we have some tools that make things a little bit easier for us, but still there's a lot of APIs and a lot of different concepts that you're going to have to interact with. And that's where AI tools like Copilot can be incredibly useful to help you along that journey. So in this video, we're going to prompt Microsoft Copilot for assistance with implementation of authentication and authorization mechanisms. So I'm starting with just a very simple web app here. This is just a stock web app from .NET. And what I'm going to do is I'm going to prompt Copilot to try to generate us a minimal API with some just basic authentication and authorization features. And so I am going to go ahead and open up Copilot. Now, the way you can do that, there's a few different ways. One is to use the desktop application, which you can access down here. Another good way is to come over to Edge, and you can use something like, say, copilot.microsoft.com, and this will bring up Copilot. There's also a really handy sort of extension up here in the Edge browser that comes built in, and so you can just pop that open as well if you need Copilot. So I'm going to go ahead and access it through the desktop application. Now, the first thing I'm always going to do when I start Copilot is I am going to say, start a new chat. Sometimes it's not real obvious, but it'll have an existing conversation going on, and that can confuse Copilot. Copilot has what is known as sort of a context. It's sort of the information it has about the current conversation and about you that it's using to generate its responses. And so if you have past conversations in there, it can get a little bit confused. It'll be like, why were we just talking about one other thing? Now you want to talk about coding. So always start with a new chat. And so Copilot is just this handy AI tool that you can interact with. So I am going to say something like, please build me a .NET minimal API with 2 endpoints. One will be the unprotected root route, and the other will be a protected route. And let's see what it comes up with here. So you can see here, it's setting up JWT authentication. That will work. We could have specified to say that, hey, I want cookies or something like that. But now one thing to note here is that it'll often do things like add in use authentication and use authorization, when we actually know we don't need to add those because those middlewares are automatically added if you add a service for authentication or authorization. And just looking here, it looks like we have authentication, but we don't have authorization. It does say we have require authorization here. So this gets us a decent start. I'm going to go ahead and take a step back. And so sometimes you need to give these tools a little more information. Now, I had pulled up some documentation that I think is particularly good about what I'm trying to do. This is on Microsoft's Learning Resources. So I'm just going to grab a bunch of this text down to where sort of the relevant parts are, and I will copy this whole huge slug of text, and it's going to look very ugly putting it into the text, but this should help it sort of do a little more what we wanted. Please use this documentation to automatically implement identity and map the API endpoints. I don't really want to do all the work of that. I'd rather use the newest sort of best APIs that .NET is giving us. And so you can see here, it has figured out that we want to add identity. It kind of doubled down. We're adding identity, then we're adding identity API endpoints. But we can work with this. So let's go ahead and take this code and we can copy it over and clean it up a little bit. So the first thing I'm looking at here is we got this application DB context. You would want to put that down below your top level statements, but I actually don't need that. I'm going to use the default identity DB context. So let's change this to identity DB context. Now, this is where having a little bit of domain knowledge allows you to steer these tools. We're also going to have to install these dependencies. So that's something you could, again, ask Copilot for. So say, please give me the command line code that I would need to run to install Entity Framework Core and in-memory database. And what else are we going to need here? And identity. Let's just see if it'll pick it up with that. I do believe we will need a bridge between identity and Entity Framework Core. And you can see here it picked up Entity Framework Core, Entity Framework in memory, Identity Entity Framework Core, which is that bridge, and then Identity API. And I believe we just need identity. So I will grab those. And so again, you can't always perfectly trust what you are getting from these tools, but they will get you close. So let's install Entity Framework Core, and then let's install in memory. And then let's install bridge between Entity Framework Core and identity. And then lastly, let's go ahead and make sure we have identity. And we should see a whole lot of our squiggles go away. All right, now we have a bunch of code to start with. Now I know I don't need to add identity and add identity API endpoints. So I am going to go ahead and get rid of this, but I believe I will want to initiate those stores. And let's change this to be our entity DB context. Excellent. Now we have our DB context, we have authorization, we're adding our API endpoints. So let's go ahead and see if this now works. Do we get any more squiggles? And I don't need this authorize here. We can just use require authorization. And then I don't need any of these. We don't need the redirects. We also don't need to add those middleware. They will automatically be added. And then I can get rid of a bunch of these other imports that it had sort of hallucinated in. Again, this isn't sort of a perfect process. One of the first things you really need to realize with working with a tool like Copilot or any other AI tool is they have a tendency to do what is known as hallucinating. So they will essentially say something very confidently like, oh, you want to use this code, when in actuality, pieces of it may be incorrect or the entire thing may be incorrect. So you need a discerning eye. That has sort of been the goal of this course, is to help you have enough knowledge that you could use a tool like Copilot to do something like this. And then I'm also going to get rid of this as well, because this is built in behind the scenes. And now I think we are as clean as we need to be. So let's go ahead and create a new file here. Let's create a new requests.http file. And we're going to populate this with some requests that we will have Copilot generate. So I'm going to go ahead and copy this code and let it know that this is the code I went with. And now one option would be to say, this is the code I went with, and then paste this down. But now in Copilot's context, it has sort of memorized these other patterns that we didn't actually need. So I'd actually prefer to, instead of doing this, start it with a cleaner context, that it only sort of is looking at the code we're actually going to use. So I'm going to say, this is code I am working with, and I will say, please generate a requests.http file to create a new user, log them in, and then make requests to my two routes. And then it looks like it made us a couple of pieces of code here. Now, I'm not going to use these tokens. We're just going to use the built-in identity tools. And so again, there it's trying to sort of enforce a different authentication scheme than the one we're using. So let's go ahead and try this register. Now, it may or may not have gotten this right. And in this case, I believe there is not an identity here, but let's try to send that real quick. First off, I need to start this. Excellent. So now we have that working. This is the unprotected route, which is what we wanted. So I can access the unprotected route. Now let's see if I can get the protected, and it did not pick up our port. So we need 5014. Now a handy shortcut, I can select this 5000 and hit, I believe it's Control D, and now 5014 and replace all of those at once. It's called using multiple cursors. Really, really handy. And now I can access that route, and let's see if I can get the other one, and I cannot. Okay, so let's go ahead and see if we can register a user. So if I send to this, I'll get a 404 not found. So now going back to those docs I was looking at, come down. Now this is one of those things, again, this might be context that you would feed to Copilot before you have it work on this. But I believe we have a /register, login, refresh, confirm email. So these are the routes we actually want to use. So this would be excellent context to feed to Copilot to have you generate routes like this. But so I want to get rid of this identity. And now let's try this. And so it looks like I don't have the right username and password. So Copilot hadn't quite given me the right information here. So if I come look at this, register actually needs an email and a password. So it got us close, but not quite. And then we will need to make this an email. It will yell at us. And there we go. So we have now registered a user. So Copilot got us close, and we just were sort of able to sort of tease that over to get it where we need it to be. And now I know this is not going to be correct. We actually want to pass in the same information here. And now you can see here, we got a token and a refresh token. And I actually want to say, use a cookie. And so let's go ahead and say use cookies equals true. And now I get back a cookie. And I believe I have my cookies set to work. And there we have that cookie was saved in our IDE. And now that was used to make that route. So now we have had Copilot help us create some protected routes, as well as create a suite of HTTP requests that we can use to test those routes. Now, this is a great example of a spot where these AI tools are excellent for getting you sort of up and running really quickly, but you often need to sort of diagnose what's going on. If you run into problems, it's really useful to feed them more context. Go find some good documentation on what you're trying to do. Often they won't have the latest, most up-to-date APIs. There is a knowledge cutoff in these tools, often 6, 9, even 12 months in the past. And so if you're working with an API that was released within the last year, you will often need to feed it information because it isn't aware of it at all. And even if it is, it often won't have had enough training data to understand it really, really well. It'll often try to mix in older APIs and older ways of doing things. So go ahead and grab the context you need, feed it in, and sort of massage the answers. Don't try to get it to do everything for you. This is a tool. It's a partner. You can sort of think of it as like having your own personal intern that can help you sort of get you close, and then you as the professional can help sort of walk it into where it needs to go. Every vulnerability left unaddressed is a vector for attackers, exposing applications to potential breaches. Identifying and addressing these issues is essential for building secure, reliable software. In this video, we will describe common security issues that occur in code and how to identify them using automated tools. Let's begin by examining common security issues in code. One common security issue in code is SQL injection. SQL injection happens when attackers insert or inject malicious SQL commands into your application to manipulate the database. This kind of attack could allow unauthorized users to access or modify sensitive information in your database if successful. Another common security issue in code is cross-site scripting, or XSS. This is a risk where attackers inject harmful scripts into your site's page, potentially infecting other users' interactions. If an attacker enters a harmful script, like a command designed to display a fake warning or manipulate the system into the comment field, and the system does not properly clean or filter this input, the harmful instructions can run when others view the page. This could allow the attacker to access sensitive information, disrupt the website, or compromise user data. Next, let's examine the security issue of authentication flaws. These are weaknesses in login security that can allow unauthorized access if not properly managed. Imagine an app that doesn't lock accounts after multiple failed attempts. This could allow an attacker to keep trying passwords until they break in. Another security risk is insecure data handling. Insecure data handling is when sensitive information isn't adequately protected during storage or transfer. For example, imagine an app that stores credit card numbers in plain text rather than encrypted. If an unauthorized user accesses the database, they could access and misuse this data. Encryption scrambles the data, making it unreadable to anyone without an access key. So even if someone intercepts the data, they can't use it. After you have identified issues in your code, you will need to implement a strategy to safeguard it. You first need to review and prioritize security issues based on risk. Using a tool like Copilot to scan your code can help you find code issues and categorize them by severity, such as critical, major, or minor. These security levels help you understand the potential impact of each vulnerability. Critical issues are the most urgent because they can lead to significant security breaches. To reduce security risks quickly, prioritize high-severity vulnerabilities like SQL injection. Once you've prioritized vulnerabilities, it's time to implement the necessary fixes. Apply fixes based on tool recommendations. For example, in the case of SQL injection, Copilot may suggest parameterized queries for SQL, while other platforms might suggest stronger session management practices. Both of these strategies will help safeguard your code. In this video, you learned about common security issues that occur in code and how to identify them using automated tools. Identifying vulnerabilities before they become problems keeps applications safer and reduces the risk of costly breaches. Authentication and authorization code can be some of the most difficult parts of a code base to get correct. And when things go wrong, it can be really difficult when you're stuck and you just hit a wall. And that's where AI tools like Microsoft Copilot can help you get past your auth issues and back to making meaningful progress. So in this video, I will explain how to use Microsoft Copilot to identify and debug security vulnerabilities in code. I have 3 different projects set up here. Now, the first one I want to go through, I am calling bad config. Now, over the years, the amount of boilerplate code needed in .NET has come down exponentially. But setting up operations like authentication and authorization still involve you to set up a bunch of different things like a database and your authentication, authorization, identity, gluing the two together, making sure that you have your routes set up. So all these different things. So this is an application I put together. It is relatively simple, but at the time I had forgotten one of these steps to make this actually work. So the application is currently running. I have these 2 routes. I have the root route and I have this protected route. I should be able to log in and get access to that. But if I come over here, I can make this request to my root route, and that works. And then if I want to come down and try to register, I get a 404. So there is an error here. So I am going to copy this code. I am going to open up Copilot and see if Copilot can give me a hand. So as always, I open up a new conversation to make sure I have a clean context. And then I'm going to say, I have a bug in this code. When I try to make this request, I get a 404. This is my app code. So I had forgotten to also grab that request I was making. That's a piece of context you'll want to make sure it has. So let's grab that request. I will put that in here. So I'm saying I have a bug in this code. When I try to make a request, I get a 404. There's my request. And then this is my app code. So let's go ahead and see what it can come up with here. So it looks like you're missing an endpoint to handle the register route. And so now it is proposing here that I make this register route. Now let me see if it understands about the map API functionality in identity. Is it possible to automatically map the register route using identity? And so you can see here, it missed. We should be able to add an app.map identity API down here. But let's go look at their code. They pull in the user manager, and then they make a new model for registering. So we get the email, user manager, create a sync. And so this might work. I could take this and I could try to run this code. But this is a time when Copilot didn't quite catch what we're actually looking for. It did catch that we're missing a route to do our registration, which might lead me to go, oh, I'm not mapping those routes. So I could then go back and make that change to my code. So I could come back here and go, I need app.map identity API, I believe. And then read. So I can come back to the app here. I can go app.map identity API, and that will need my identity user. And that is the code that this was missing. Now, if I save this and reset, I'm not sure I have all the right imports here, but let's go ahead and give it a crack. And now we get a 200 OK, so we can register. So this is a great example of you're using Copilot, you have a problem. Again, maybe it doesn't get you to the perfect answer, but this is sort of like a phenomenon known as rubber ducking. It was this idea that as a programmer, you would keep a little rubber duck on your desk. You'd sort of talk to that rubber duck, explain your problem, and in that process, it would make you think of the right answer. Often when I'm working with tools like Copilot, I find that it's sort of a phenomenon like that. In thinking through the problem and then maybe seeing even an incorrect response back, it helps me sort of shake loose the cobwebs and figure out what it was I was missing. So that is the first example. So this next one I'm calling crypto fail. And so this is similar to the cryptography code we used earlier in this course. This is a bug I had sort of introduced at some point. My code wasn't quite running right, and it took me a little bit to find out why. Now, it is a really simple bug, but it causes a pretty decent issue. So if I run this application, so if we open up a terminal here and .NET Watch will run this new code, and let's see what's going on here. And I will go ahead and close that last request and that last program. So let's open up the crypto fails requests. So now this should be similar to our encrypted messaging app. So I should be able to get all my messages. I should be able to post a message. I should be able to then get a message back. And so this is supposed to encrypt this message when I post a message. And then I should be able to get that message back. But I'm getting this error. I'm getting a 500. The input is not valid. Base 64 string contains non-base 64 characters. Big kind of confusing error there. So let's go ahead and grab this code and let's say what is happening. So if I come over here to Copilot, I'm going to again start a new context because I don't want to confuse this app with the previous app. I have this code and we'll put the code in and say, I get this error when I try to get message at ID 1. And now this time, instead of giving it the request, I'm just sort of roughly explaining what's happening. And then we'll just give it that stack trace there rather than pick through it and see what's up. So often with a problem like this, I will start by giving it all of my code, the whole error, and not try to figure out what's going wrong necessarily first myself. Maybe I made the first pass, couldn't quite figure it out. So I'll just give it the full context before trying to trim down to find exactly what's going on. So here it says, it looks like the error occurs because the content property of the message entity is not being encrypted before being stored in the database. And so it looks like it picked up on the right issue. So what's happening in this code is, let me make this a little bigger. You can see down here, it had looked like it was a problem with this route when I'm trying to get an ID, but it's actually a problem that occurred when I wrote that message because I'm not actually encrypting it. So I make my encrypted content here, but when I make the message and save it to my database, I don't use this new encrypted content, I use the original content. So I'm saving an unencrypted message. This unencrypted message then can't be decrypted because it's not in the right format. So if I change this code to reflect what they said here, where the message content should equal encrypted content, then we should see that this works. Then we can test this out. Not sure if the lack of a hot reload picked that up, so let's go ahead and restart that. And now I can send messages. I can post a single message, make sure there's a message in there, and then I should be able to get that message. So that fixed that bug. Again, that was just a bug in the way I was writing this. I was creating the encrypted content, but then I wasn't actually setting the message to be the encrypted content that it should have been. And this is a really great example of a spot where when I was first looking to debug this, I was looking in this route because that's the route I was hitting when I was seeing the error, but it actually happened in another route. These types of bugs can be particularly difficult to sort through, but you can see here Copilot was able to almost instantly pick up on exactly what the problem was. Then this next project I'm calling data access. So this one has a data access issue. In my program here, I will actually just demonstrate what's going on. And then we'll see if we can get .NET to help us figure it out. So I have this code base, simple web app. I have the root route. I have a protected route. Then I created this logout to be able to let users log out because it's not a functionality automatically implemented in Map Identity API. So they should be able to hit this logout, then go ahead and log them out. And you may already spot the bug. Again, it took me a few minutes to figure out what was going on here, but this is the kind of thing that Copilot can be really useful for. All right, so I've got a terminal open here. We'll do .NET watch, and we should be able to see this fire up, and then I will open up these requests and show you what's going on. And so if I send a request, I can get the root route, then I can indeed register, and I can go ahead and log in, and then I can hit this protected route. But if I hit my login route, I can still hit this protected route. So even though I thought my user was logged out, they're still able to access it. And that's a huge security problem. So if we look at my code here, we can see that we have our logout route and that this protected route is indeed protected. So let's go ahead and see if Copilot can sort what was wrong with this. Then let me go ahead and start new chat and say users can still access protected content even once they hit my login route. What is wrong? All right, so it says it looks like there's a missing piece in configuration. I've done add authorization, but I haven't specified any policies or authentication schemes. Now, it sort of hallucinated a little bit there. So it's trying to figure out to add some more things. I don't actually need to do any of that. But if I look through the code here, it did pick up what was missing. And that was this sign in manager, sign out async. So it found the problem, but it actually doesn't tell us that it found the problem. It thought I was missing some stuff with my authentication scheme, which I'm actually not. In this case, the code we had is otherwise fine. So again, this is a bit of a hallucination. But if I take this line and add that down here, we should now be able to log out. So that was sort of a situation where, it found the right answer again, but it did it in a really convoluted way. I wouldn't want to take all this extra code, and that's where it's upon you, sort of topical expert, to know when its advice is good or not. Really do think of it as an advisor. So we can make sure it gave us the right line there. So if I go over to my requests, let's give that one more crack. All right, so we can get the root route, we can log in, we can hit the protected route. Then if I log out, I shouldn't see this. And perfect. So that actually fixed our issue. And again, the huge glaring problem with our application. Users should be able to sign out using this route, but it wasn't actually logging them out. And it was just this one line of code. The code ran perfectly without it. I could have done all kinds of testing and just not happened to try to test it after I logged out. So always make sure you're testing these routes when you're creating them, especially when you're using a tool like Copilot, because again, that tendency to hallucinate. Now, these will get better over time. These models have continued to get better over time. As this version of .NET becomes more stable and more used, you'll see a lot better success with it. We're sort of pushing the bounds of what Copilot knows by trying to use this really modern .NET syntax of these automatically generated APIs. And so that is the final example of this little Copilot demo. So hopefully that gives you an idea of some of the types of debugging that Copilot can help you with, some of the things you'll want to do with giving context, making sure it has the right information. Again, think about it like a partner, and remember that you're the topical expert. Don't depend on Copilot and assume it's correct. Always verify and check what it's doing, because it can be wrong and often is, depending on what you're working on. If you're working with sort of older versions of .NET, older syntaxes, it's going to be more successful because it's had more time to learn about those things. But these really modern syntaxes is really going to struggle. They're really powerful, but they're hard to diagnose with Copilot. And with that, I wish you the best of luck in all of your working with authentication and authorization. Congratulations on completing security and authentication, part of the Microsoft Backend Developer Professional Certificate. Throughout this course, you've gained essential skills for building secure, reliable, and scalable applications, from managing user identities and protecting sensitive data to leveraging AI-powered tools for security. You've learned to apply key principles and best practices that are critical for today's developers. You began by exploring how to secure APIs using ASP.NET Identity, mastering user authentication, managing roles and claims, and integrating external authentication providers. Next, you delved into role-based access controls and JWT authentication, learning to define and implement RBAC, secure API endpoints, and apply best practices for effectively using JSON Web Tokens. Then you tackled the core concepts of data protection, including data encryption, data masking, secure storage, and methods for safeguarding data in transit to equip you to maintain confidentiality and integrity in your applications. Finally, you leveraged Microsoft Copilot to implement and debug security features. You explored how this AI-powered tool enhances secure coding, simplifies authentication processes, and accelerates issue resolution, culminating in a capstone project that puts your knowledge into practice. Having completed this course, you now possess the skills to secure applications, protect sensitive information, and implement modern authentication systems. You are prepared to navigate the challenges of backend development with confidence and build applications that inspire trust. Congratulations on your achievements, and best of luck in your continued journey as a backend developer.